So today I'm just going to be talking and working through with everybody, hopefully, how it's possible to use Spack-Stack containers that EPIC has been putting together to build and run UFS software. Pretty much anywhere that's Singularity will run on. So, so first things first, yeah, we're recording the event, so turn off your cameras. The idea here is to have this be like a hands-on thing, so where we can all work through these things together, run into problems and work through them and figure out what's going on. So any place, I recommend if you can log into any HPC machine available. I know Hera and Ursa are down today. Hercules and Orion, I think, are supposed to come up shortly, but maybe not yet. But if you can log into Gaia or S4 or Derecho or any basically Linux box that you have access to that has Singularity installed on it, that will work. If you are not logging into one of the, or one of these pre-configured machines like Hera, well, Derecho, Hercules, Orion, Gaia, Jet, I recommend you download the Singularity image that we'll be working with today. And here's the address. Can you guys see that? Is it big enough? So I could. Yep. Maybe make it bigger.
Do you have it somewhere that we can click, because this is too much to type?
Let's see. Let me share this. I'll share my presentation, and then you should be able to do that.
Alex just shared it in the chat.
Oh, okay, great. Let me open it up to everybody. And I don't know, I think that should work. Are people able to access that?
No.
Some people are, at least. So while it's definitely easy, the easiest way to get this is to pull it down with from the S3 bucket. You could also build your own version. That'll take you probably at least 30 minutes to build on most machines. But these images are available via DockerHub, and you can build that directly with Singularity with that command that's below. Oh yeah, we could just share this whole link in the chat too.
I'm gonna have to go upstairs. The network connection is not stable on this machine.
I'm sorry?
Jet.
Yeah, Jet will be fine. Okay, so yeah, in terms of expectations, I'm going to be switching between the slides here and then some basically my terminal screens. I recommend people open up like 2 terminal screens to wherever they're logged in, so they can, in one screen they could be shelled into the container, and the other they can be on the host system. And I'll be kind of working through the examples and everything as we go along and try to get the F11. Let's see if that works over here.
Sorry, can you give the URL again?
No, other keyboard mark.
Oh, this one?
Yeah.
Oh, yeah. But that's probably where I need to get that button.
And
This button.
maybe reduce the bar, the sidebar.
Yeah.
One column.
This is, I think. There we go.
Thank you.
Okay, that's better. Now do we have it in the chat? What the link is to the?
You have an image in the chat. Sandra knows.
What's it?
There's something in the chat. I don't see it.
Just give the chat open so you.
Oh, I see. I came in late. Can you do in the chat again so people who just got the chat up can get it as well?
Yeah, let's do that.
Thank you.
VPN isn't going to work. I'll see if I
Or
can
at least
put
on
it
the
in
screen, one of
places.
the others.
All right.
Itself.
So you can, yeah, just use wget to pull the image there, so it should work. Okay, so as I was saying, the idea here is try to work these together. If you can have two terminals open to one of these machines, that'd be great.
Mark,
yeah.
just you shared this what is pointing to image, but you should share this this Google document so we can click on Google document so we can have
Right.
access to other stuff. Because image is already Alex already put image. That's not the problem. You just take that Google Docs you have on your.
Actually, if somebody else could share, that would be great. Like share the link, because I'm kind of, I can't seem to get to the thing over here. So.
Oh yes, that one. That one. And then chat.
All right, here you go.
Yeah, thank you.
Okay. So as if, you know, if you have questions, please ask. And we will be monitoring on Slack too, to some extent. So if you have other issues that are coming up that aren't necessarily related to this off the top, you can bring them up there. So again, basically back to getting the container, you can build it. We have also containers for Spack-Stack 1.9.1, but everything in this presentation, this workshop is going to be dealing with 1.6.0. And so here are some of the locations that these containers exist on the tier 1 platforms. So there's no need to download there. You can just use these containers where they are. Unfortunately, I just can't really.
Mark, one more time. Sorry, am I the only one who cannot see your link in the messages?
Same here.
No, it's not there.
It's the chat in the meeting session, yes.
Um,
Oh, I see it.
Got it. Thanks, Mark.
So here I put in locations for all the images. So that's the folder where they contain. You're looking for this Ubuntu 2024-Intel UFS 1.6.0. And again, I'll put that in. So hopefully people are able to access those. So basically here, just kind of give you an overview, the motivation for why we put together this approach with containers, and what we're hoping to get out of it. So basically, like pretty much all UFS software, as I'm sure most of you know, utilizes Spack-Stack. It's very difficult to build and time consuming to build on your own, particularly you just, are coming into this whole environment. The containerization really eliminates that process for users. They can just download the container or use it from where it's already installed. The initial idea was to design the container so that when you shell into them, they look pretty much like a tier 1 platform. You've got Lua modules there. Spack-Stack is installed, and you can just load up everything you need and build and run internally. But we're also going to talk today about how you can build stuff with containers and run it as if it's native on the host system. And, by allowing that process and trying to educate people on how that works, we hope that this will, make NOAA software a lot more accessible to the broader community. Also, we are hoping that will allow us to stop supporting quite so many native installations of Spack-Stack, because it's, as I said, it's very time consuming and resource intensive to try to keep up to date with that and installing them everywhere. So we're hoping to use these containers on some platforms going forward, at least, and get people on board so they understand how they work and feel comfortable using them. So this workshop will be dealing with Spack-Stack 1.6.0, which is where the weather model is still, I think, sitting. We have 1.91 is available as well, but like we had to start with something. So there are multiple ways to use the containers. We're going to talk about that today. We'll work through it. And we are hoping that once people kind of understand, we'll get some, help from the broader community to adapt or adopt the containerization approach to all the various and sundry repositories that have hosts already built into the repos, where they expect it to be on some pre-configured host, and maybe we can get them to
A
add.
number of people on Gaia C6 are reporting they cannot see the
You don't have
container.
any shared.
We don't have permission.
Okay, let me.
Share.
Yeah, Mark, that's sitting in prod shared, not world shared.
Okay. Then we're gonna have to.
Anyone outside the project won't have access to it.
All right, let's go and.
If you use the download link, you can get it for there. I compared it to the one on disk on Jet. They're bit for bit identical.
All right, let me. I'll copy that over here, and.
If you paste that path into the chat, into the in-call messages, that would help, because we cannot copy from the presentation.
Alex, can you copy that path in?
Yep, just did. So that's on Gaia C6 now and world shared, so everyone should have access.
I'm going to get this started because I'm going to have to regenerate the module file. So.
Are you saying that should be viewable now? I still can't tell us.
No, I'll make this a bit bigger in a second. All right. Sorry about that. Hopefully now people can see that on Gaia, and hopefully on the other machines they're still viewable by people. So just a bit of background on the containers and some of the basics. There are multiple kinds of containers. Docker is one. Singularity and Apptainer are two others. They're almost the same. They were basically Apptainer. I started as a fork, I think, of Singularity. It's supported by a different group, but they are largely compatible. Apptainer will accept singularity as a command and singularity env as an environment variable that it will recognize. Singularity will not recognize Apptainer env. So that's a little bit different. Also, Apptainer will prioritize Apptainer env over singularity env. So it can be a little bit nuanced. Most of the software that in the scripts that I've put together try to recognize whether you're working with a singularity or Apptainer. But for most users in general, it's you can use them interchangeably. So as I said, we're trying to provide an environment where you can build it and then run UFS software simply and easily. There are, you can also extend these containers, and we've done that on multiple occasions. We have containers that actually have the full software built into them, SRW, NDA. Global workflow is in progress on that. So we're not going to go into that right today, but we're just going to try to get people to understand how the Spack Stack works, and hopefully that'll help you all understand if you run into problems when you're going forward, what might be happening. So also with containers, you can write a sandbox. You can create a writable sandbox. We're not going to do that in this workshop because it's not necessary, but just to put it out there, that is a an option. All the containers images, I like to think of them as sort of like, just has software like you have in your, /user or whatever, /opt directories on an HPC system, which you can't write to either. So you can bind your the host system to the container, so you can read and write directly on your host system. And the container just thinks it's like, cross-mounted basically to it. And you can easily copy files out of the container. You can't copy them into the container unless it's a sandbox, but you can copy them out. And we'll be doing some of that. So yeah, basically you still do require a few things on any host system you're going to be working with. Obviously, you need to have Singularity installed there or Apptainer. If you want to build, you're going to need Docker also, but you can just download these images. If you build them locally, they should be bit for bit identical. And you're going to need to have, if you're going to run with MPI, you need Intel MPI or MPitch installed. Both of those will work with the MPI that's installed inside the container. Usually srun is the preferred way to run these MPI executables from the host, but MPI exec will work as well if it's Intel MPI based. You're obviously going to need a fair amount of disk space to build and to build and run the software, or build it doesn't take that much, but if you need several hundred gigabytes to put all the data you need to run. Also, if you're working on a desktop, if you have Slurm and Rakoto installed, that will help a lot. And the ability to install a virtual Python environment would be helpful too. There are these Rakoto fake Slurm, which is actually really helpful. It's part of the SRW. You can actually just pull it out of there. And Rakoto you can build on your own, so it's pretty straightforward.
Mark, I still have a question on building. You said you need Intel. Does that mean that you combine with the Intel that's in the container and they have to be conformal in that way?
It just needs to be MPitch based. So MPitch, MVA pitch, because Intel MPI is MPitch based. So
binding is going to be worked out.
It will work out from the host system srun or MPI exec to the container. So
you're compiling externally then with the compiler outside of it.
Yeah, we'll get to it. We're compiling inside. So here are the two main commands that we're going to be dealing with today are Singularity shell and Singularity exec. So shell is very much like you're SSHing into a different machine. But you can bring in some of your environment depending on what flags you use when you log in. You can't write in the container, but you can bind the local system, so you can write there. once you shell in, you'll have the full Spack-Stack available and opt Spack-Stack, Spack-Stack 1.6.0. It's all the little modules are installed there. And you can load them up with this command with the module use / opt Spack-Stack blah blah blah. Alternatively, there's Singularity exec, which basically executes an executable that's either built by the container or is contained inside it. So you run Singularity exec, path to your image, and then ls/slot/opt, and it will show you what's in the image under /opt. And we're going to use exec to both build and run without shelling into the container at the second part of this workshop. So, okay, let's finally get to actually doing some of what we're going to do and shell into the container. So, this is still me as role epic. So I'm going to do this. Can people kind of see that screen okay? Make it a little bit bigger. So I'm going to start with exporting my image. Oh, this is world shared. Make sure it still works for me too.
It's a little fun because the man you just gave is covered by here is by the picture of us.
Oh yeah,
So we
that's,
actually typed it. I didn't see what you typed.
what I tend to do is I make the path to my image, Singularity image, an environment name, an environment variable, and I just call it img. That allows me to do things like, see if I can move this out of the way anymore. Can't really. Maybe I can move this, but then you won't be able to see anything. So
It's the other mouse. There you go. Dot.
oh, can I hit the dot?
Get the dot.
Or is it?
Over on
Right here. Okay. Thank you. Okay, so what are we going to do here? Yeah, let's shell in. So first of all, like if we make a temp directory, let's just make a temp variable called it. And we do Singularity image. Okay, now we're in the image. We do echo temp var. It gets passed in. Now if we do Singularity shell -e, that tells Singularity to start with a brand new environment. We do not have.
What is that first command? Is SSHN?
Yeah, Singularity shell, and then $image.
Singularity space shell?
Yes, yeah. And then if you add the -e, you start with the fresh environment. So you pass no environment variables in.
I don't get any environment variables even without the -e.
Where are you?
I'm on Jet.
Jet?
There a variable that explicitly says to pass the environment?
It's a good question.
Can I option or environment variable?
I think there is, but now I don't know what it is offhand.
Jet, the shell command doesn't work. The shell command doesn't work. What should I do?
Where are you?
Jet. Singularity shell.
Oh,
What are these command? Yes, yeah.
Do you have your image set? The path to your image?
No, I have the path to the image from the Google.
Okay. I will follow this.
All right, one other thing, if we want to bind to a file system, we're going to add the -b. So we're going to do singularity shell -b. I'm on Gaia here, so I'm going to make sure that we're binding to GPFS. $image. We are sitting, in the image, but we're bound to GPFS F6 and in my directory locally.
Excuse me. You've got on your slide, numbers. Try shelling into the container. You get like shell in, you get 4 different commands.
Right. Those are just different things, different ways you can shell in.
You need to be using, because I'm getting all these like warning, error.
Okay. What's
Warning, password file doesn't exist in container. Warning, root file doesn't exist in container. Warning, skip mount /temp doesn't exist in container. Skipping blah blah /bin/sh doesn't exist in container.
and what machine are you on?
This is C6. Let me try again.
Is anyone else succeeded in C6?
I'm fine getting singularities, not my path anymore. On path 10.
Singularity shell -b dollar in the first one.
Yeah, so, well, I can try the other 3.
You don't have to try all of it. It's like my bash is like, if you have, like, if you do dashing without that, then it will not give you any bash profile.
It's working for me on Jet other than environment variables. So if you have access to that, to Jet, you should try it.
Then I'm on Jet and I cannot run the singularity shell. Can you?
I am able to.
June, what is singularity in your path?
I can run singularity, but singularity shell doesn't work.
People are not typing the image correctly. They're giving it a different file.
Yeah, I don't know. It seems weird.
So you something.
All right.
What error are you getting on Jet,
I did
June?
not, I did not. Am I? I don't know.
Sorry, mine is I cannot set the export. I may use different shell. Let me double check.
So of all those shell is.
When you do export IMG, just send it right now.
Yeah, but it's yeah, I do it last. I see that.
All right, so that's what it should look like on Jet. Basically, just once you set, if you guys can see hopefully you can see. Unfortunately, on Jet, I had to put it in under my own personal directory, but if you can get to it. the Singularity shell should work there. You had any more luck? June?
Yeah, I just.
Let me try yours.
I cannot say it.
So you're running.
Mark, you know what the module load is to load the Singularity?
You shouldn't really need to do that on most machines, but there are some that you do. And it's usually either module load Singularity or module load Apptainer.
Oh.
Um,
So this, I think it should work if you just do like Singularity shell and then use that. Then
We Singularity.
the dash B.
The system kind
Shell.
On that, it's user given Singularity.
Okay.
And then,
Okay.
or,
Yeah, you're actually going to do a second Singularity command once I have run Singularity.
no, once you've logged in and you're logged in, just this, it should say like Apptainer at the bottom or Singularity at the bottom,
I have
you're
that,
shelled in.
But I can't bind to GPFS. Singularity shell minus B fails.
You may not have to, because where are you on?
I'm on Gaia C6.
I think it's okay without. It depends on what all is in the, I put a whole bunch of things inside and, okay, so
Now it's working for me. So
it's working? Okay, good. All right, let's move on to the next thing. So,
by the way, Mark, sorry for the commands you listed 4. Do we need to do 4 or just 1?
no, just one. I just wanted to demonstrate what these, what they are, what they do. So let's just, as long as you are logged into your Singularity and you have your local, if you do PWD and you can see your local machine or your local file system is what I mean to say. I'm going to do all this in Sandbox. No, actually, get out of here. Okay, so within the container, opt Spack-Stack 1.6.0 has all of Spack-Stack installed in it. It's under env, unified env, install module files, core. So that's what you're going to want to load or module use.
Within Apptainer, I have no modules. Module command not found.
All right, that's actually very true. And I think I skipped ahead on my slide. So, oh, geez. That one closed. That one closed. Here we go. So if this last one, if you use this /-s /bin/mybash when you do your Singularity shell, so let me do that.
I didn't do that. And I find module.
GPFS dash you can also bin mybash $image.
Okay.
And I think actually what you're also going to want to do is start with a fresh, you want to do -e because the module files, the module paths, if you don't use it to get a fresh environment when you shell in, the module paths sometimes conflict from the host system. So you want to use that -e, unless like yours doesn't come in anyway. But so now you can do module avail. You can see the Spack-Stack is there. If you can't do that, like basically what this bin mybash does is, I'll show you what it is. It sources this bash.bashrc, which is, it just runs a few things like sources the lmod, which is in user lmod init bash, and it sets up your module use path just by by default when you log in. You can run those commands yourself to access the modules as well, but as a convenience, if you use that -bin/bin/mybash, it'll all get set up for you. So now if we have module avail, we can do module load, stack intel one API MPI, module list, module avail. Also show you all the modules that are available, which is pretty much everything that you want to do. Okay, so if people, hopefully people are able to.
Module
what'd you
not
get?
found.
Okay, then try running. So you want to do like, you probably have to init that. So if you do source / user lmod init bash, then do module use and the path, opt spack-stack 1.6.0 ends unified env install module files core.
This is for chat here.
It's for anything. Once you're logged into the container, you can do,
Can you copy and paste in the chat? Thanks.
Or is it because the module line was split in the presentation?
Maybe if yeah, it's possible if you copied it from there, but there it's in the chat. Okay.
Which one should I?
You might just load stack intel and stack intel one API -MPI, because what we're going to do is we're going to build some software real quickly. And I mean, you can see, if you want, you can load up like UFS, weather model, ENV. Should be able to anyway.
Yeah, FPN says it's free to be available with MPI for it does. This is on guide C6.
MPI iFort is in the container, and iFort is also in the container, as well as all the other, Intel MPI, and it's built from Intel's HPC toolkit Docker image. So we started from their software and built on top of it. So here, let's try. I put in a couple of sample programs in /opt/sample programs in the container. So I would start from a empty directory on your local host system. I'm going to copy everything from opt sample programs to this directory. So there's three. There's a hello world parallel, and then a netcdf.-pair .f90. So to start with, let's build hello world. So this is it's the simplest program you can imagine, right? So we're going to do iFort hello world -o hello world. We can run it, and as expected, it says hello world. Then let's also build this parallel world, hello world parallel. So this time we're going to need to use MPI iFort to build it. So we'll do that, MPI. And if you run it as in serial, you know, it's not going to do a whole lot. It just runs as if it's got one thing, but you could also run it with MPI exec-n4. You can see, okay, we got, you know, 4 different processes, and, you know, it says hello from each one.
Mark,
Mhm.
so where exactly should we be? If I do a PWD inside this Apptainer,
Mhm.
it says I'm in role epic.
So did you CD to that or no? You were on your host system when you shelled in?
So I need to get out of this completely crazy.
That's probably what happened. So CD to someplace on, like, you know, your scratch space, and then shell back into the container again. Yeah, if you try to start it from a
Yeah. right.
some directory you don't have write permissions to or
Right.
anything, that's probably what caused all your issues.
Yeah, it's probably cutting and pasting your.
I'm CD to writable space and it's giving me read-only file system. Yes. So there's some permissions issues here.
So where are you on? You're on Jet, or you're on,
I'm on Gaia C6.
what does PWD show you?
George, try making a test file from the host machine, just to test that it really is writable.
Okay. I'll try that. This will take a minute.
I'm able to write to the directory about within the container.
Correct. You can't write inside the container, but you can write on your, whatever you got on the host system, your file system. So if you start from a writable location and you've made sure to bind that directory, and so sometimes you have to bind, sometimes it will automatically pick it up. But when you shell in, if you type PWD, it should show you that you're on, you know, on the host system, hopefully where you started.
Yeah. So how do I find that?
When you shell in, if you give it a -B, capital B, and then slash the root of, you know, wherever you're starting from.
So I'm in the container, I think, and I think I shell when I was inside and nothing was working. But I'm trying to do CD, it says no such file directory.
Okay, so exit the container, I guess.
And how do I exit?
Just type exit.
Oh,
So how do I run the MPA exec, because it's not working inside the container?
MPI exec did not work?
Yeah.
Did you load stack Intel and stack Intel 1 API MPI?
Chat, I cannot find the hash text. You just share in the chat. Spack-Stack.
Did you shell into the container?
No, I just log in chat. Directly.
Okay, well, now you have to shell into the container.
But to run a shell container, I have to do the working loader there.
You have to do what?
I have to load some modules, yeah.
Inside the container, you load the modules. So set shell into the container, and then if you use that /s or -s/bin/mybash, you'll be able to load the modules directly.
So once you're in the container, you can't navigate around directly on the host system.
You can some, but not all of them will be bound. So like if you particularly like opt will not be there because you'll have the opt from inside the container. Yeah, so you should be able to look at almost anything under GPFS that you could normally look at, you know, obviously.
You could default something then goes to a default show.
Should be, yeah. But sometimes things like, you know, like if you have data on like /contrib, but you're running from /scratch or something, you have to explicitly tell the container to like mount /contrib, or else it won't see it and you won't get your data.
So you can mount any directory that you write permissions to, add the singularity command, and then you can, while you're in the singularity, you can just write to the.
Yes, you can. And you can mount to places that you don't have write access to, you just can't write.
And I'm still getting, it's not right, the directory permissions are 777. I did singularity shell minus E minus B, current minus B, that directory. And I was seeding that directory before I did singularity shell. Minus S,
Let's see. Let's get it.
I don't do
You don't mind me driving. That's what happened. I'll let you find that.
Lowercase e, the image,
I used to use it.
and then dash
So just
B
exited from that.
is the,
Private.
but I'm not.
So where are you?
Oh,
I'm on Gaia
So
2.6.
what is this directory you're in?
I'm in,
I'll stack the receiver.
Yeah.
So if you do singularity,
But I'm still not.
singularity shell,
Yeah.
Oh, it's, it's not.
shell dash capital B space slash GPS.
Okay, please.
I'm gonna paste this, but I'm not.
No, just type it. Just type slash GPFS, just to make sure we get the.
Okay.
Mark,
Space.
just-
Hold on just a second. Dash S. Space slash bin slash dash. $sign image. And now see if you can write.
Sam, were you able to run?
On what?
There you go, I think.
Hello World.
Yeah, I run both of the hello worlds.
Read-only file system.
Maybe an if statement that says, if this is Sam, work, else spread. That's my guess.
That's weird. I don't
Sam,
know.
Sam, I want to
I get it.
ask, so for slide 17, when you
I even
run hello world on
When I write in
another
that
terminal, will that work?
dash B slash NCRC.
Minus B slash NCRC.
Yeah, because that's your home there.
This is really a symlink though. So this. should-
Okay, that's why. So it doesn't see those symlinks in the container.
Okay.
So add the dash, so like if you have that, add the dash capital B slash NCRC, and then you'll be able to, it'll see your home directory too.
Okay.
Sorry, June, did you have a question?
Yeah, for slide 17, you said try run the software from the host. Do we expect it to get error?
Yes.
Okay, just want to confirm.
Okay, you skipping ahead, I see. So yeah, like let's try to run it from the host. In some cases, it actually will work, depending on how close your system is to.
My battery ran out. Boy, this battery goes fast.
So yeah, if you try to run it from the host system, like let's try hello world. Yeah, from Gaia C6, it won't work. The libc is different. And definitely the hello world parallel will not work either. Now you can run if you use singularity exec. So yeah.
Before we go there.
Yeah.
I'm trying to run the parallel with the MPI exec. Can I get a hard responder?
Are you, oh, did you shell in
Yeah.
with dash E? Try shelling in with dash E because I think it's probably.
Is that for environment or something? Yeah, with E is for the image, right?
Yeah, when you do singularity shell dash E, you get a clean environment, so you don't bring in any of the path from your host system.
Because that's getting me on that module.
Yeah.
Both of you hands up.
Is the order of dash E and dash S matter?
No.
So when you leave, you lose your environment. You have to do it all.
Yeah, I mean, but reload your modules when you log in.
I mean, Gaia, I'm copying of sample programs to localhost
Mhm.
and give me can you create regular file, read-only file system?
Okay, so are you like George was just having this problem with, if you have some symlinks to like your home directory on Gaia, or anything like that, you might have to add a -b to /ncrc, because on Gaia, the home system is a different location, right? It's under that /ncrc.
I haven't verified if that worked yet because my PC just shut down. This is going to be a 10-minute process thing.
So I would recommend trying, when you log in, to add an extra -b to it, capital B /ncrc, like, and then you'll actually be able to see your home.
What can we use on,
On chat, it might just work because isn't Jet like under /home?
well, I tried -b on my home directory.
Let's see. Like, geez. Okay. So I mean, if you're just starting from home,
So I'm starting from scratch space. It's like that. That's right. But from -b, well, I tried -b to the working directory to my home directory, but it all I just look at the read on my file system.
LFS 5. So what was the command you used?
Similarly shell pointing at a soft link to the image -b directory and over
So you use a soft link where?
for the image.
Maybe try setting it as a variable.
I with that.
Oh, so it's as a variable, not as a soft link.
Well, it's a variable pointing to a soft one.
I'd just make it a variable pointing to the actual full link. That might add extra complexity and cause problems. Okay, so sandbox. Right, so getting back to
When I'm trying to run from the host, it says leave MF, so it's not found. I think we need to load the module. So how do I do that?
So did you shell into the container?
No, I'm trying to run from the host, the executable.
Oh, okay, and it doesn't run.
Yeah, because it's not finding leave MF.
Yeah.
So I need to load the module.
No.
Oh,
So, okay, you're getting to the point, like, right, that's the whole point, is that you can compile these codes. If they're really simple, they might work on your local machine, on the host machine, but if they have any complexity at all, they're not gonna work. But you can make them work by doing a couple of things. Like, so here, like, if I run hello world on the host machine, libc says it doesn't work. If you run singularity exec, hello world.
it's the module.
Oh yeah, I need the dollar or the image too. I haven't set the image. Okay, so if you run singularity exec image, it will work. And in fact, if you try to, let's do the parallel one, and that one doesn't work because it doesn't know It can't find everything it needs. However, if we run srun, and you can add, if you're unfamiliar with this, you can run srun from the head node. Just give it some extra stuff like your account information. And I think I've got more than that. So let's see. No, I had it in my history here someplace.
I get S1 in your path.
This is on the host system.
Okay. Oh, so we go back, now we go back to our,
Yeah, we're going to try to run in this stuff from the host system.
yeah, right, so I don't exit another shell.
Yeah, that's, I was recommending people log in on two different, terminals.
Oh, excuse me.
Mhm.
Yeah, so I added the -b in CRC when shelling to this thing. So again, I got the kind of create regular file, the Word file.
And where,
Gaia.
which directory are you in?
I think I was in my home directory. So should I go to?
Try seeding to a scratch directory and see if you can make it work from there. The bind should work for home, but it could be that you need some of these. You might have to add an extra layer or something to your because some of the file systems on these machines are actually links, and it can confuse Singularity. That may be what is happening in some cases.
Hey, now as with Apptainer counter, all my code directly come with only system.
I'm sorry, what?
I cannot write to my own directory when I run the shell command, after running shell command.
You can't write to your own directory. Try again. Try going to a scratch directory and shell in from the scratch directory with the -b. Are you on? You're on Jet? Are you on?
Yeah, yeah.
So -b/LFS5 probably.
Yeah,
Yeah, listen.
yeah. From that, it became read only.
All right, that works. So.
Oh, so you can go to the same directory that your Singularity is mounted to, which you just did there, and then run srun. I will just compile it.
Yeah, you can run it from the host system, or you can try, right? So that was what I was just trying to do here,
Got it.
is run. So run this parallel version with from the host.
I went to
So Mark,
Yeah.
couple of lines up, you've got srun N4 account build, couple lines below your cursor right now. /hello or Carol. Should that be an MPI run in there? MPI exec?
So we're using srun instead.
Yeah.
And actually, I think we need to use.
Basically, if it is inside a batch job, then.
MPI, PMI, yeah, that's PMI.
So iFork is working, but when I use IFX, I'm getting the leaf IMFS. So it's not.
Sorry. So this is the whole point. That's what I'm trying to get to as we get to. So. Yeah, and if you try to run that, if you compile the netcdf par, it also will not work. So the way we got to do this is we want to basically pass some information to, when we run Singularity exec, we want to pass in some information using these special environment variables. Like if you start any environment variable with singularity env and then underscore, you can add, like, you can set like the LD library path that will be used by this executable when it runs with singularity. So we can pass this stuff in so that it'll get picked up when it's run inside the container and it will start to work. So let's, from the container, like, let's just do this, the more complicated one too. So like here we are on the container. Where am I? That's on Jet. Oh, and we're gonna load module load, that CDF par, no, that CDF Fortran.
I'm also able to run this from a VJet compute node.
Okay, good. I just want to see to compile. So if we want to compile that MPI code, we're gonna add this. So basically you have to link in the netcdf Fortran lib. So that's add this to the command to compile. If we run this from inside the container, we get, it writes out 4 files. We can see them here. Now if we do nc dump of like one of them, we can see it's a simple file. It's got 10 ones in it. Basically the rank of the MPI task that wrote it out. So if we try to run that from the host system, we're going to run into a bunch of problems. So first of all, let's see, when we run it, first error we get, can't find that CDF. So here's the thing. What we want to do is we want to tell Singularity exec how to get to that. And from inside the container, we can find out what we need it to be. So we can echo this, that CDF Fortran lib. And we can see, okay, that's the path that it needs to have to pick that up. So now from outside the container, we can do export singularity env ld library path equals, and we copied out from the container, right? So this is going to tell it to look under /ops/spack-stack blah 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 for the Fortran library. So now if we run again, no, it looks like it didn't work. Did I spell it right? Let's do it here. It's still not finding it. I don't know why. That's weird, because it should.
Should it be Apptainer?
I'm sorry?
Should it be Apptainer by any chance? Is it Apptainer environment also, right?
Apptainer accepts. Apptainer will accept both, yeah. And in this one, I'm pretty sure. Let's see. It's actually Singularity on Gaia. So, well, my point here was supposed to be that it would find that, but not the next thing. So, because it still won't work. What we really need is the full library path that's inside the container.
No, I mean, why would you go, wouldn't you just do that? Wouldn't you just?
Find the whole library path.
Well. Well,
No, the whole thing?
well, when you went outside, when you went back onto the host, you just exported the INV and then loaded the modules. Wouldn't that be the way to do it?
Mark, did your srun command run singularity exec? Does it need to?
Oh, yes, that's the problem. Yes, you are right. Thanks. I knew I was forgetting something. So, yeah. So now if we do, right. So we're going to do the singularity exec of that parallel thing. And
So you need to like make sure.
yeah.
Yeah.
All right, now, so now it finds it, it says, okay, yeah, we would prefer Apptainer or whatever, but, or, and now we get a different error, so it can't find lib IP for it. I think you were finding that also. So we could set, we'll use the entire LD library path that's inside the container, and we'll set that. Singularity, env, LD library path. Now we'll do this again. And we'll wait for resources. Hopefully that'll come up in a second. I'm going to try this on a different debug. Debug sound. Oh, is it the Q? Is that what they can do? Yeah, let's try that. Let's try it with this run. No, that didn't work either.
You still have partition as debug too. Yeah, go back to batch. There you go.
All right, so let's see, we have there. Yeah, okay, backwards. Well, normally you don't have to wait this long to get it to run.
No, I was.
Well, I'm just gonna go with the spoiler alert. It still doesn't work. There's one more thing you gotta set, which is you are gonna need to set this FI provider path. And in order to get it to the FI provider path is basically how MPI connects between the container and the host system. So we're going to need to set Singularity env underscore FI provider path. And I'm going to do that now. So that, oops. With all that, this should actually run when it actually gets through the queuing system. But the whole point here is that this is a lot of work to do to get something to run. So there has to be a better way, right? And there is. You can write a wrapper. And that's what we provide, a wrapper, or a script that will create a wrapper for you in opt container scripts. It's called externalize.sh. So this is something you're going to run from inside the container. And when you run it, it's going to basically write a little script that wraps up your executable and provides all of the paths that are needed from the host system to access everything inside the container. So if we're going to do like to run that, you are going to be in the container here. And we're going to do opt container scripts externalize. And the syntax is you give it a -e, which is going to create a directory or, write to a directory if it's already there. We're going to call it extern. And I'm going to give it the full path to this netcdf-par executable. Okay, so that ran through a bunch of stuff. What it really did here is it created a wrapper file in this extern directory, which it just created. And this is what it's got in it, a bunch of stuff. So it provides the name of the image and where it's located on the host system. It sets these Apptainer env provider path and provider, and the LD library path to use, the library path to use inside. It adds some other things, an empty ESMF makefile, which isn't important for this particular thing, but in some cases it'll set that correctly. And it'll set all that stuff up. It has the name of the executable that it wants to run, and then it will run it using Singularity. So once this is created, you can run that directly from the host system. And we could just do srun instead of with all the Singularity exec blah 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 stuff. We can just run it to or go to and if it goes through, it will run. Try this from chat too, I suppose.
That extern NetCDF part is actually a script, right?
It is going to run that script.
Right.
Exactly.
So this script that basically sets some environment variables. At the end, yeah, so that's that. And then at the end, it calls Singularity exec. And presumably the srun that you did to launch this is not running that on all the 4 cores. It's just that executable is going to get launched on all 4 cores.
The srun will launch it on all 4 cores, like it does.
If I had echo statements over there, right before the argument, say echo something, 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 will I see 4 times of that lines of echo?
I think you will.
Can
we can try it. Let me get.
Because I'm asking this is a more complicated system that is shortly, I think.
Let me try it from Jet, where maybe I can actually get a. Oh, actually, I don't know if I'll be able to run it on Jet either because I don't think I have any allocation there under EPIC. But let's see. Copy that back. Be faster. All right. All right, so let's test your question. Yeah, it runs. It'll run it 4 times. So, so it's basically, it's just like, I mean, it's running like it's a regular MPI or a regular, it's being launched like from srun, like anything else. So it provides as many threads as you've asked for. Why do you ask? Is it?
Well, I'm curious about this. So if you look at the MPI code, right, and it has some complexity with its intercommunicator with the MPI world.
Mm-hmm.
srun is managing that.
From the host system, srun is, it sets up all the whatever MPI threads that needs to be run that you know are being requested, set them up to run across whatever nodes you have. So it's not just on a single node. Like, so if you're, that's another shortcoming of running from inside Singularity is like you can only use one node at a time. You run from outside, the srun connect across all the nodes. It launches, literally, I think it launches a Singularity executable for every thread.
Right.
And so, and then, but you can specify that you want, say 4 OpenMP threads per, you know, MPI executable. Those MPI threads will be available inside the container. So you can use the OpenMP inside the container and it all works.
Right. And that's where I'm getting at. Once you have very complex MPI code that has intercommunicators, so there are ways in which the comm world might be sending out various fine grain and coarse grain parallelism that's embedded in the kernel of the code, right? So as srun then distributes your executables, each one of them is a thread within the container. So that you have to start to actually think about how you're designing your code. So how many are contained within each thread and how many are communicating outside the threads in your combo.
Well, it works the same whether you built it in the container with a container or not. So, I mean, if you're running code like the weather model and you wanted to, use, 2 threads per MPI core for the MOM6 model and 4 for the atmospheric model, that's all handled just the same way. You run srun and it, like within the MPI executable, it handles all that. So basically the srun, and all it does is just interfaces between the MPI that's inside the container and the MPI that's on the host system.
Yeah.
So,
Bottom line is all that stuff is done in the MPI executable and in the MPI code. It is.
You're going to have local threads.
it doesn't, like the threads are the threads. They're shared across the host system, and the host system gives those threads to the container and then it's run. So
Right, so I'm wondering how that's going to scale when you have multiple threads on one compute node that's in the container communicating across other.
it scales the same way every other MPI. Yeah, it scales the same as every other MPI executable, whether you built it in a container or not.
Right, so the overhead that you go through the context switching is what you might want to be concerned about then in that case.
So far, what I've seen is there's a little bit of overhead when you launch with Singularity versus not, but once it starts running, the overhead is negligible. So
right, so within the MPI communicator, the connections that are made within the backbone are the same, and so they don't have the context switch.
Right.
I want to go back because my laptop crashed. What we're doing in this exercise, we're building inside a container and then we are running outside the container.
That's right.
I've gotten as far as building.
Okay, good. Yeah, the next thing I was going to do was have us build I think I got to get where I am. Let's build the weather model. And while it's building, we can take a break. So it's from the inside the container. Let's clone the weather model. And if you don't know what what the Git repo is for the weather model, I will paste it in. You want to use, I'll just do the whole thing. Okay. So let's clone this. We need 2 dashes for the recursive. What the heck? You might want to do this from outside of there.
I've lost that -s thing again. I need in order to get an environment.
Yeah, I tried dash dash. It's a different. It's dash dash. Remove that.
Remove the dash?
Yeah, then try dash dash. It works.
Oh, I have the.
Looks like it's not dash.
Oh, it's not a real dash?
Yeah.
Yeah, I think, okay, when I copied it, it got screwed up. Okay, there we go. Yeah. So once we get it started on the build, and we can maybe take a little break, come back, and then I'll show you how we can externalize it and run it. I have a sample run directory everybody can download from S3, and we can we can just run through a quick example and then we'll take a break for lunch, I guess. And for the afternoon, so this first part of the workshop of, trying to show you how you can log into these, shell into the containers, build stuff, externalize it so that it'll run on the host system. And, so get people to understand how that all works.
Where's your UFS path here?
What are you doing?
I'm trying to clone the model.
Oh, git clone -- recursive. HTTPS, github.com/UFS community/UFS-weather-model.
UFS-community.
Don't you know this by heart, George?
I do not, because I do not usually based from someplace, one of the many places where I have.
UFS community/UFS-weather-model. I'm disappointed.
Command is in chat.
Where? Oh, that's why I haven't singularity.
Got that right the first time.
Yeah.
Let me ask a basic question. So, but now, for example, on Jet3, I see your share to your image. That's already created by you for Jet specific.
No, it's the same image everywhere.
Oh,
So that image is the same. It's the same one as on Hera, it's on Versa, it's on Gaia's, Derecho, Jet. It's all the same image.
Oh.
And so it looks exactly the same. I mean, it's literally bit for bit identical. So
Include all stack Python modules.
yes. And in fact, if you build executables with this container on any machine, you can copy them over to a different machine and use the same container to run them. I mean, you'll have to rework you'll have to re-externalize them for the local machine because the paths will be, the host paths will be different, but the executable will be the same. And so you can move these things, once you build them, you can move them around.
Wow.
And that allows you to, yeah. And it also, what I'm hoping is if we start using this for testing for like RT, we don't have to test the same thing on every machine. Like we could test, because if it runs on Jet, as you know, it's going to run on Hera or Ursa if you built it with a container. Now it still makes sense to test, you know, is the data in the right place and is it all that,
We're
but
really testing what fixed files are and how to support infrastructure.
So the code will run.
Yeah.
You
So
made
Mark,
one.
I'm in the container and I got the spec Intel 1 API error, just like Elmo has detect the following error, but yours is Intel stack Intel and mine is stack Intel MPI.
what did you try to do and what happened?
Load the two modules, right? So I see you have one error about stack Intel when you load, and I have the error message for the other library.
So were you able to load stack Intel?
Yeah.
And
Not one. Yeah, this one I have error.
on the stack Intel 1 API MPI?
So in the slide, it said stack Intel 1 API.
Yeah.
I have,
I think I typed that wrong.
Okay.
Yeah, it is just stack Intel. It's not stack Intel 1 API. Yep. Out here.
Just stack
MPI. There we go.
Okay, thank you.
Sorry.
If you're compiling Spack-Stack only once, doesn't that mean that it's been optimized for the processor on which you compiled it?
Actually, we generally build Spack-Stack, and this includes on natively with a low, like we don't use a lot of optimization because for that very problem or issue of like if you use if you build it on like Ursa with brand new compile or brand new CPUs, it won't be compatible with Jet or something older. So we tend to build the Spack-Stack even natively at a very low level, and definitely in the containers. So we don't use huge optimizations for that. So in that regard, yeah, some of the underlying libraries will be slower than if you built it natively with all the optimization for the libraries.
But you're saying you don't use those optimizations anyway?
Generally, we don't when we build the Spack-Stack. At least that's my impression of the way it's been done. I haven't done them lately, but
no, that's not correct for the current Spack-Stack. We basically use whatever the kind of Spack default optimizations are, which usually uses the most specific one for a CPU family.
All right, thanks, Alex. There you go. But
so it might make a difference in the runtime, but we don't really know how much yet.
Yes. Yeah, for that reason, it definitely will not have as much of the optimization as you would have on a natively built Spack-Stack.
True, but how much time do we spend in library calls?
Right. I mean, exactly. Yeah, that's
yeah.
Mark, it's been a while since I've worked interactively with a Singularity instance. And it's my recollection that once you go in and mount within the Singularity and you start building stuff and creating directories and removing directories, doesn't the image file itself grow?
Not if it's not writable, it doesn't affect the image. So like the image.
Right, because you're mounting the directory separately now,
right.
Keeping the image itself static.
Yeah.
And you don't operate in that way, you won't run against that.
Correct. Yeah. Okay. So like if you made it a writable sandbox, then yeah,
that's right. Yeah, and you said we weren't necessarily doing that for that very reason.
It's also, yeah, when you make a sandbox, particularly with these images, like you can make a really lightweight Singularity image, but these are not that. These are very heavyweight.
Exactly.
And so like
go in there and disrupt it.
If you created a sandbox image, you were going to get like a gazillion little files that come with like /user and like all sorts of things. So yeah.
I've downloaded the model. Is there another module I need to load, or just is it ready for CMake?
Okay, you're in there. What do your module lists look like? Okay, so you need to load up Stack Intel -1 API -MPI. Okay. And then you want to module load UFS weather model -env.
If you've written it specifically.
And you might have to load I load SP and CRTM.
So I think
you can make a build directory.
And then what's the CMake command?
The CMake command is -the app ATM at the CPP suites. I can copy and paste it into the thing if you want.
So Mark, that app we are working on the current NOAA machines, the modules set up by those system managers. Do we have extra benefit to use this similarity?
So, right. Well, mostly the people that are installing Spack-Stack on these machines are the EPIC team, and some like Alex Rickert works on it as well for EMC. And what we would like to do going forward is not support quite so many of those machines. And to move to containerized Spack-Stack on some of them, particularly like for example on Ursa. the EPIC SI team spent a lot of time building Spack-Stack 1.9.1 natively on Ursa, but there's still some demand for people to use Spack-Stack 1.6.0 over there. Well, rather than spending all the time to build, because you got, whenever you move it to a different machine, it takes a while to build Spack-Stack. So instead of doing that for 1.6.0, we'll just put the container there and put the containerized modules there so that you can build against the container. And in the second half of the workshop, I'll show you how we can do this without having to actually shell into the container. And then, but like.
So container will be easier for system manager.
Yes, yeah, it'll be easier. I mean, it makes it easier for a lot of things. It still does add there's one extra layer of complexity though, which is that, like when you build against a container, you have to externalize that. But
the system manager has such container and then it can convert it to what you want to use by all of us.
So I'll show you in the second half, after we get back from lunch, we'll work through some of that.
I don't build, I always use file.sh.
Okay.
And then I'm trying it and it's saying system default change modules.
Yeah, see, that's the problem with using the shell commands to build things. It's just like they go through and think, well, what's your, what system are you on? And like look for, detect machine and all that stuff. So if you want to use them, you have to go into the guts of them to adjust them. You can still get them to work, and we'll, in the second half, hopefully we're going to get to building the global workflow. And so this is where what I'm hoping is we'll get, once people understand how the containers work, we can get EMC and PSL and whoever else is working on in the various UPP and the weather model and all the subcomponents to go in and add like container or, so that it's a supported platform,
Right.
So right now container is not a supported platform by the weather model. That's why compile.sh doesn't work. So,
That's why we're here.
so.
We're here.
No.
One question here, if we do $3 executables, right? Will it have any negative?
We're saying this while Rahul is not here.
Right. Because he's.
So it shouldn't be, the containerized executables will be probably a little bit slower than if you built them natively. Usually it's in the overhead when you start. So when you first start up, but if it's a long running, forecast or something, the difference between native and Singularity is going to be just very, very marginal.
That's loading stuff into the container.
Once everything is running, it's pretty much the same thing. Yeah. Except like, Sam was mentioning that the Spack-Stack in the container is not built with the same level of optimization as you would get on the native, but those are library calls, which again are, in the margins. So
I don't think we can really conclude that, but I'd say most probably it's true.
Mhm.
I think people will need to test to make sure.
Yeah, I haven't done any extensive testing on the performance in a while. That we did test it a number of years ago with FE3, just the die core, and tested it out to several thousand cores, and the difference was just minor.
It was just a pre-programmed.
Yeah, it was just like it was a benchmark case.
You gave it really heavy.
Yeah, it's pretty big anyway. It's like 2,000.
Did you go across the hosts on the network?
Well, different compute nodes on, I think I ran it on WCOS, the Acorn, some tests there. So.
Right. Right, so it.
about the exercise. So I have the run command, and then it works, but it's only route out the initiative out 000. And I think that 4 times instead of doing 001, 002, 003.
Yeah, good. That's what it's supposed to do.
But no, it says right out 003, 2, 1, 000. It only happened, you only write out the 000.
Translation of that.
On,
Systematically. Then you just.
I think we can take a break for lunch, and come back at 2.
Yeah.
That's my backup.
So it up these company existed from a previous exercise.
Okay.
So and if you do like analyze the consider this is the only one.
Totally. Let's see.
Oh, you don't have that.
Sure, we have a badge.
We're meeting back here, I just told them I'm building like a cafeteria.
I don't know why. I guess maybe everybody's
Yeah. It's not. Outside.
Oh, yeah, 2 o'clock. Let's go back at 2.
I'll try it.
Oh.
Yeah, I was thinking.
Add,
I don't want to do it.
this is MPI. This tells Esra what libraries you can use.
Yeah.
Somebody has.
It might be because you would not all, plug to yeah, mine was working.
Did you get the model?
Mark, question
Yeah.
about is 5 linking issues.
No.
Hold on a second, Natalia.
Yeah,
I'll come over there.
Yes.
Yeah. I'm not thinking there's
Come back.
The one who was.
Oh, yeah.
You're supposed to do this today, but.
I choose one.
But it looks like you were able to get it to, you could write everything to your.
It seems like,
Oh, is your scratch and it works better?
Yes.
Anyway, now.
Yeah, there must be some, I think that there's I think there's a soft link on the host, on the system itself that puts your home in someplace that somehow doesn't get picked up by Singularity unless you do get special. Hopefully that will.
Okay, thank you.
Yeah, I got as far as building the model.
All right, did it build?
Yeah.
Okay, cool.
I don't know, like, fortunately, I got the process is moving faster because I also do make it CMake some depending on the build shells. I set up the environment myself and then proceed.
Okay. Yeah, like in the afternoon, we're gonna build the model from outside the container, and then we're gonna download the global workflow, and I have a patch that you just apply, and it adds like container or containerized as a machine to all the things, so you can run the build all script. And those are the kinds of things that, if we want to get this adopted, we're going to need help from people to do that.
I had built global Google workflow building in the fall of late fall 2023, I think. I got everything except GDAS-app build. GDAS-app wouldn't build because it does get checkouts and CMake get checkouts which are generated by it was horrible. So it didn't work.
I have gotten it to build. I don't know if it builds directly with the patch that I have right now, but I've gotten it to build.
Everything else built, and the way I built it was I went outside the build script. I just set up the environment to point to where all of the dependencies were, and I did CMake with the CMake options that were specified in the build.
Yeah,
and they all built.
Yeah. Natalie, what?
Yeah.
Oh, did it work? Okay, good.
Thank you.
Natalie, did you have a question? That was you, right?
Yeah, I
That was
had a
us?
question, but I think I solved it. I had a question on Gaia C6, but I think I didn't provide the name of the output file to write to, and that's it was 2 lines in the in the slide, but it works fine.
Okay, good.
Thank you.
Where I differ and where I put all the dependencies is every dependency is in a flat directory structure. So it's flat directory root /live has all of them, and directory root /include has all the includes, and directory root yeah, it had all of them. The CMake just put whatever the paths are to these things inside directory root /live. So you only have to make CMake prefix path directory root, and all of the tens of dependencies were found.
Oh, good. Yeah.
So you didn't have to load a module for every one of the dependencies, which Spack-Stack does require. Downside of that is I can't support different versions.
Is the stuff you're doing right now for just prep work for what we're doing after lunch, or should we keep going?
Yeah, I was mostly just kind of doing that for prep for after we start back up. But yeah, we're taking a break here until 2 o'clock Eastern.
Okay, sounds great. Thank you.
Sorry.
Thank you, Mark. It's going, I think, really well. Everything.
Yeah, it's a little bit of some hiccups at the beginning, but hopefully people are getting the idea. And that was what I wanted. I wanted people to actually use these things, shell into them, see what they look like. Because I think people, they may have tried before and been frustrated, and obviously people were frustrated a little bit at the beginning, but I think they're figuring it out, so it's all good.
Hey, Mark. Can you hear me?
Yeah.
Oh, hey, sorry, this is Mike Barledge. I had to step out for the previous hour. I was going to catch up here over lunch. I see that you are currently on slide 32. Is that how far you made it?
Yeah, we didn't actually make it all the way to here.
Okay.
I mean, if you get to the point where you can build a model, that'd be awesome. And yeah, hopefully I now have the slides correct. Have you run into any problems so far, or you're doing pretty good?
No, I've been doing pretty good. At least on Jet, everything seems to have been working okay. So I'll catch up here while you guys are at lunch.
Great.
Okay. Thank you.
Hi, Michael. You were wondering if I'm here.
Yeah. Sorry, I was just typing something up, but well, I'll just ask you. You know, I don't want to diminish all the great stuff you did for getting the Spack-Stack built on Mac, but I'm just curious if you see this container route as like a way to run UFS on the Mac.
There is a different stack or container version for Mac, which is called OrbStack.
Okay, so this is something that EPIC is working on?
GCSDA has
Okay.
started doing OrbStack since the version 1.9.1. I personally haven't looked into it yet. So building Spack-Stack is one thing, but making it work is another thing. Making it work with running apps, and I'm not sure this has been tested yet. So
I just saw this morning, Natalie and Mike, that the new Mac OS 26 is going to support containers, Linux containers natively. So again, like Natalie is saying, like we haven't tried to run against them, but if you previously you know if you wanted to use a container on a Mac, you had to like install some sort of like emulator, Linux emulator, and then install Singularity, and then so layer upon layer upon layer trying to get it to work. But I think with this new OS 26, if it supports it natively, then you could just should be able to shell into this container like you do on any Linux platform, and hopefully run against it the same way too. But yeah, before when I had tried using the emulator and the container, I was able to build, but then when I went to run, it failed with weird seg faults, which may have been, I think Natalie, you might have figured out what was causing those anyway. Maybe that would fix it. So I'm not sure, but anyway, it seems like a step forward if we can run containers natively on Mac. That'd be cool.
Yeah, so looking at the OrbStack, maybe that's the thing, the exact thing that you're talking about, OrbStack. No, it doesn't ring the bell, the name.
No, I mean, this just came, I came across my news feed this morning that like it was announced yesterday or something that they're going to support containers, Linux containers on Mac OS with the new release. If you do like Mac OS 26, search on it in Google, I think you'll see some of these came out about a day ago.
Yeah, so that would be really interesting. I know we even wanted to do training for running it with Mac OS, and it is possible that we'll just use the regular way of building it, because there are several attempts or several ways to build it on different system, different architecture that has been tested already. But eventually, I think the if containerized Spack-Stack will be available for Mac, that would solve a lot of issues. So it's like running the executable. You just need to do some kind of a wrapper script. But yeah, it's pretty exciting. So let me take a look. You said Mac OS 26?
Yeah, I think it's going to be called Tahoe, it looks like.
Tahoe, T-O-F-A?
No, T-A, Tahoe, like as in Lake Tahoe.
Lake Tahoe, okay, interesting.
Let's taco.
Yeah, thank you. I definitely will look into it right now.
Sure.
Oh, Aaron, did you have something? Or
oh, I'm sorry. I thought Mark was the one talking. Sorry about that.
No, I was, but
oh, because I see another face lighting up.
yeah, I just saw your hand raised, Aaron. I was just wondering because I was going to ask Natalie if if she's had any success with getting her instructions going on Sequoia, since I'm sort of just keeping all my systems on Sonoma and I'm getting some pressure internally to update my OS. But I tried on a home machine with Sequoia and it failed the build.
Oh no, I was just trying to, I thought Mark was there. I was just gonna ask him something real quick unrelated, so I didn't want to interrupt, so I apologize.
Okay. Oh, Denise, yeah, I think I saw that, Denise, in the conversation on GitHub, but
Yeah, I don't remember what the details are, but yeah, I was definitely able to get it because I have the same issue. I'm keeping one machine at 15 and one at, or I guess it's really the command tools, the Xcode that's the issue.
oh, okay. So are you on your Sequoia build? Were you still using like 15.3 or
No,
some
you
older
can't.
version?
You can't.
Oh,
Right.
that's
Once
right,
you-
right. 16. Yeah, you need 16
Right,
at
right.
least. Right? Okay.
So, but yeah, I was able to build, and I've run here on this laptop. Yeah.
Okay. And that's what do you remember the command line version?
Well, it's probably whatever is native to Sequoia. Let me find.
So I was using the most recent version, something.
I think it's 16, 16 something.
Okay.
Does that sound-
All right, I'll give it another shot. See if I can get it.
Yeah, and I put the notes in whatever that document Natalie was maintaining. I was able to build it, and I definitely run on this machine, so I know it's possible.
Okay, that's all I need to know. It's
On
possible.
Sequoia?
Yeah.
Okay.
Yeah, that's what this laptop is. This is 15.5.
I found the note about the containers. I found an article about supporting native Linux container on the putting it on the chat. Support for native support for Linux container. That's really interesting.
Try one more. Yeah. You should be able to look at the battery pack. I should have a little light on it too. That would be why. I guess I'll do it. Find the original plug in. Yeah. Oh yeah, I noticed it. Is that working? Charging. Yes. So Sam, I've never actually met you in person. Brian Curtis.
Hi. Is it? Thank you. I have a ridiculous question. Does anyone have a bandage? I want to stop bleeding on
I
things.
think I do. I'm so sorry. I think I do.
Good, good. I mean, my finger is calming down, but
I'll separate your things.
I have no idea how I cut my finger, but it just happens.
And the
It's
I
fine.
have not six sides.
It's thinner.
Oh, it's thinner?
Yeah, it's smaller. This one is.
Okay, okay.
Thank you.
You're welcome.
So we left Docker building them up.
Right.
Were you guys able to get the model to build or? Cool. If you want to try running it, I mean, you don't have to, but I'm gonna take control of this again. You can use this link to pull up basically an experiment directory down.
On the externalize first.
Yes, you do have to run the externalize first. So yeah, do that, externalize and put the new executable in wherever you want to put it, extern or whatever.
It is.
Who are you talking to?
If they responded.
Why did I get an illegal instruction exception?
What happened with your building or when you were running?
That's when I was running. I'm running it inside the container. I just finished building.
Where are you running it from?
This is VJet.
No, but I mean, like, do you have an experiment directory that you've downloaded or?
Oh,
are you
this
running
is the C48.
It should run.
VJet has older processors. Maybe it's compiled, maybe it's optimized for newer ones that are on Hera and KJet and such.
See if I can hopefully it'll run for me on here. Yeah, it runs on.
Guess this is why you need beta testers.
Yeah, I can only test on so many places. You see, I did have one of my things was open on Jet though. I haven't built it over there yet.
For me, the UFS server model is not compelling.
Mine compiles, but it doesn't run. It says illegal or illegal instruction exception, which is exactly what I would expect if it was optimized for one of the newer processors running on an older one.
Okay, I'm compiling on Gaia C5.
C5, okay.
Yeah, and group module or some file is not compiled, saying some name is not found or something.
So you shelled into the container.
Yeah.
And
Loaded all the modules. I was following this.
did you use the -E when you shelled in?
Yeah.
Okay. Let me look at this.
So.
Oh, Mark, when we download the data C48 case, which directory do we need to be in?
If you download that tar file, then just untar it someplace, probably, like at the same level as the UFS weather model, so it's not underneath it, and then CD into it. It should be called UFS underscore something 1. I copied it from, it's UFS underscore warm start 1.
Mm-hmm. So it needs to be at the same level or the same level as UFS weather model or right under it?
I would put it at the same level or, I wouldn't put it underneath it. It probably won't matter, but I wouldn't put it underneath the weather model.
Yeah, they don't put data inside
So I know
code.
this comment.
So then srun. I just wanted to make sure that uh, the input file is properly listed. The path to the input file is.
Let's try. Or maybe we can delete this folder on this.
Yeah, that might be the best thing.
I wonder where do we need to specify the input file, because they will be different in each for each user and each machine where you stage it. Okay. If it's on the same level as UFS weather model, it could be relative path.
My instructions are no longer illegal when I'm on KChat.
Oh, all right.
You have to use a specific flag. Yeah, you have to optimize for multiple. I think you're the one that figured it out, right?
Yeah, the AX option.
Yes, you have to tell it to optimize for multiple targets. So work on all of
When
them.
you build the weather model?
Yeah.
Yeah, okay. That's really slow. You're on, is this on, oh, it's on C5?
Yeah.
Shouldn't be that slow.
If you're on a shared node, it might be arbitrarily slow depending on what other people are doing. That's why I got an interactive.
Oh.
Oh, but before we do srun, we need to load the compilers and MPI
Same level as UFS, so it's decided.
on the host, correct?
Did you further than it did last time, or did it last time?
I haven't gotten that far yet. I just got mine to work inside the container. It's much easier inside the container. You should try that first.
Okay.
Whatever you did to build should get those modules.
One of the libraries is.
So Sam, when you try the test case, are you also download the run directory from the S3 bucket?
Yes, I
Okay.
followed the instructions on page 32.
You have an old image.
Oh, should it be 1.8?
No, it's an updated version of 1.6. So let me make sure I've got the right image for you.
Oh, except I didn't do srun. I was still inside the container and I did MPI exec. I guess I'll try outside next.
All right, for people just joining in now, a reminder that we are recording, so, be aware, keep your camera off, and all that same stuff we mentioned at the beginning. I'm gonna find the path to the newest container on C5.
Yeah, I found it.
Did you find it?
Yeah.
It should be.
Yeah, go ahead. When I use the 6.0, it says it doesn't have a my bash.
Doesn't have bin my bash net?
Yeah.
Well, it should. If it doesn't, then it may not be the right container. Let's see. Trying to keep everything straight where I put everything. Let's see if I can find it here.
Should I just copy from the S3?
Wow. You could, that's one option for sure. And of course, like on Gaia, everything is like commingled between Gaia C5 and C6. So
You know why I'd get complaints about libpioc.so not being found? I mean, it sounds like it's not seeing some library, but if you look at my it has some things.
are you running it inside the model or inside the?
It works in the container,
But it's
I'm
not.
trying it outside the container now,
Okay.
and it's acting like it's forgetting to put something in these paths.
You could try.
Oh, or am I running this? Am I running this wrong?
You might want to give it the number of.
Oh, it doesn't care.
Six. Let me. Oh, give it. This is on Jet again, right?
Yeah. I moved to KJet because it was willing to run there.
You could try adding --MPI equals PMI2, but it seems like, or maybe you want to, I'll try that first and then maybe try externalizing it. So like if you shell back into the container, load up all the modules that you need, and then externalize the UFS again.
Possibly did that wrong.
You don't have all the modules loaded that it needs when you externalize it, then they don't get included in the wrapper, and then it.
I thought I did, but I didn't use the exact same commands that were. Oh, yes, I did miss some. I think I missed some.
So
We
we
should
try to
try.
figure out what goes in this.
Questions. I'm Gaia, and then I just currently is with a model. I tried to log Stack-Tail. It says that it doesn't have that module. Unable to find.
How about that?
So you shelled into the container.
So I am outside the, I am not in the container. Should I be?
Yeah, you can only load those modules if you're in the container.
Oh, okay.
I don't know what this is. So now I'm live.
So for those online, what we're doing right now is we're building we finished building the weather model previously. We're going to externalize the UFS model using this command, the /op container scripts externalize.sh. We'll put the new wrapper in underscore and build/extern, and you want to give it the full path to the executable that you've built, which is pwd/UFS model. And then if you CD up a couple levels, so you're the same level that the UFS weather model exists at, you can download this experiment directory from S3. I put it in the chat link. Untar it, CD down to it. It's actually, this is not controlled to 48. It's UFS form start.
Yeah, I can't cut and paste from this presentation.
The purpose of
Containers, dash scripts.
The purpose of the externalize is to make that, creates that wrapper so that you can run it on the host system without having to set singularity and env for everything. So it does all that for you. So
If someone could paste that into the chat, that would be helpful.
specific directories where the executables.
it will, if you move the executables later, then it will mess things up. But if you leave them where they are, you can move the wrapper script, but you can't, if you move so you built the UFS model and it's in /UFS weather model /build. If you move it from there, then it'll be
But
screwed
that's
up.
what
But
the externals is doing for you, is giving you access to those executables.
exactly. So you run the externalized wrapper on the host system, and it internally goes and runs the actual executable
Right.
against the
For
container.
every one of those executables that the model needs, it has those steps that you would need to pinpoint in the container.
For every executable that you externalize, yeah, would.
Oh, you do it on the per executable.
Yes, yeah,
Okay, got
yeah.
it.
And you can actually even pass
But you
a
have,
wild card.
you have it to a directory. And so every executable in that directory is now externalized.
No, that's just where it puts them. So like, that's where the wrapper scripts go.
Okay.
Using this
Oh,
one,
what
so.
the heck?
And you could leave it, you didn't, you can't leave it as just PWD because then it would try to overwrite the actual executable with the wrapper because they're called the same thing. So that's why I put it in subdirectory.
I'm sure once we start looking at with the code, we'll get an understanding of those details.
Yeah, I need to also understand what exactly the externalize do. So what keyword I can Google to find out knowledge.
I don't know. I mean, it's like I named it that, so probably not gonna find too much on Google. So I tried to come up with a something that sort of describes what it does. And so the point of it is that you can't run, you build that executable, if you look at it, it's binary. You can't run it directly on the host system. So in order to run it on the host system, you have to create this wrapper. And so the externalize script that I provided creates that wrapper that allows you, and then you can run that wrapper on the host system, just like it's a regular
Right,
executable.
and the wrapper is the Singularity execute construct.
Yeah, so like if you need, exactly. So if you look at, the wrapper for this, it's got, Apptainer, FI provider, FI provider path, and then this big long list of paths that are all either paths on the local system, or paths inside the container that you need. So it's got like all those modules that were loaded, so it knows where all that stuff is.
Module does for you. It's concatenized.
Exactly. So
And there it is.
at the very bottom, yeah, it will invoke that singularity exec, and it'll
The argument, which is the command.
exactly. So, and it has set all those environment variables for you before it runs. So, so when it runs against the container, everything gets found, and it just works from the host.
I noticed that it's like the provider for TCP.
It's internal for the so from within
The container.
within the container,
Oh,
it's
so
TCP.
it's
Yeah,
treated as TCP, but
yeah.
it does not.
From the outside, it uses
I'm running your convert modules and something strange is happening. Saying that it can't create directory question mark MNT LFS5 question mark.
Oh yeah, give it the.
I am mounting, well, I mean, I'm not, it's.
You might have to go in there and what it really wants is, I think it needs that to be -B MNT LFS.
It wants a canonical path.
Something, yeah.
But can we run this directly from the script, from the batch script for computational job? Can we do that?
You can run the externalized from a batch script, yes.
Oh,
That's the whole idea, is like, you want to externalize those executables so that you can just use them just like if they were built natively. You're using the wrapper instead of the actual executable, but you drop that in. And that's why, like, I try to use the same name so you could kind of just replace it.
okay, but I don't like to use different names for users like me to better understand. Better understand it looks big.
Yeah.
Because inside those documents, same name but different things.
Right. So anyway, if you've gotten everything untarred, hopefully you've been able to run this or get it running. This weather model sample thing only uses like 6 cores, so and it runs through for.
So Mark, I run the model code on Jet. I got an error message on library at bc.so. I put the error on the chat.
Okay, let me look. Because Sam ran it on one of them and it failed.
VJet failed.
VJet failed, but KJet.
Quick question on the externalized script. What are we doing with that? I see it has a dash E and then something else.
Yeah, so with the externalize, when you run it, it takes that dash E is where it's going to place the executables. And if you can give it a path to any, it'll create a directory, whatever name you give it. And then that's where it will put the wrapper script. So if you can call it whatever you like, exec, or bin or something. And
Directory.
yeah, just a directory. So dash E, path to some directory, and then either the name of one executable or wildcard of all the executables that you want. So if it like you were building the global workflow, right? And you had whatever 25 executables that are all in under /exec, you can give it a wildcard for that. And it'll just build.
Some of those are soft links too.
And it does it right. It does it right because it follows the full path to it.
And if it knows anything else like scripts and things like that.
Yeah, so this externalize.sh will externalize a script also. But I'm going to show you some stuff in just a little bit that it knows better. So yeah, you'd be better off not externalizing a script. Sometimes they will work, but it's probably better not to. Oh yeah, June, I think your problem is the KJet VJet thing. That illegal instruction, or you can build, what was the flag you can use when you build the weather model?
I don't know. Ask Ragu. I don't remember it.
This is, yeah, I'll have to look it up. It's .ax and then indicate lower model, I guess.
Yeah, so June, if you, basically it's because you built on, like XJet or something like that, and or I don't know, you're built on one part of Jet that.
No, I think I built on VJet and ran on VJet. I think somewhere in Spack-Stack, there are libraries that are explicitly optimized for some processor version.
But the way are you in container? Yeah, but the containers don't do that.
No, but still, if the container is built on a new hardware, it won't work on the old hardware.
The containers are supposed to, they should be not built on, like it should be specified to use like only like core or something as the optimization, core 2 or I use like something pretty low. I don't know whether this particular error is because of the weather model or the libraries, but that's the key thing is like you just, so for you, June, you just have to run on, I guess, a different.
Yeah, just run them on KJet and see.
If I remember right, the XJet login nodes are fairly high level nodes, so if you build stuff on the login node, it will not generally work on the nodes that are lower level of CPU than the login nodes.
Yeah,
which is a royal pain. They should have left the login nodes at the lowest level.
And I suspect that's what's happening because I'm pretty sure that the containers are built with.
But it gets worse because the admin libraries are also built at the fairly high low node level. In particular, Spack-Stack is.
But you think that's some hardware issue.
You're building on hardware with an instruction set that is not supported on the hardware you're trying to run on.
Right.
I tried to build on the lower level hardware, but the lower level hardware compute nodes did not have a connection. They could not connect to the internet, so I couldn't download all the stuff I needed to do to build. At that point, I just threw in the towel and said, "If someone needs this, I'll give it another crack."
So container cannot resolve those issues.
Well, if you built it on the head node and it's pulling in stuff, anything you build new on the head node, I guess it'll figure that out or pull in some of that because it still sees the hardware. It doesn't see the.
The issue is you're pulling it on the head node, which has connectivity to all the repositories you now need to build everything. And so you build on the head node with connectivity, but you're using an instruction set that the lower level nodes, in particular VJet don't support. So you can't run anything built with the stack on those lower nodes.
Why can't I build them?
It's because of that, that extra thing I think I.
Whereas the other issue is, you need connectivity to the internet. I'm only slightly exaggerating.
All right, so as the next slide says, we're going to try something somewhat different. Not completely different, but so this is we're going to do the same thing. We're going to build the weather model, but we're going to use modules that have been externalized from the container. So I put them in all pretty much the same spot as the containers themselves. Here are the locations. Let me see if I can make that. Well, if I make it much bigger, then it'll overflow, but we'll see what we can do. So basically you're looking for wherever you found your image before, but underneath it's going to be either module files or module, and then Spack-Stack 1.6.0/core. So we're going to do this all from outside the container now. So in this case, we're going to go here. I'm on Gaia, so I'm going to do module use. We're going to use the world shared. Okay, so as you can see, I'm not in the container. I think we have to do module purge on Gaia before you do module load. But you can now load stack Intel stack, and we'll just do one at a time here. So module list. Yeah, that's why. ML works better. So module show stack Intel. So if you look here, you can see that the Lua file is actually on the host system. It's under that containers module files, but it sets a bunch of things inside that are like setting that Apptainer env and the Apptainer env library path, LD library path, all that stuff, so that basically it puts everything in your into your system. So it uses the container version, but you don't have to shell in. So now we can do module load stack Intel 1 API MPI, and we can module load the UFS weather model env, and I do SP CRTM. Now, if we do module lists, you can see everything's loaded, but here's the other thing that these modules, so I have that script called convert modules. You shouldn't have to run it unless you're on a brand new system. The idea is for, like somebody like from EPIC to put it on a roll EPIC, extract these modules, put them in one common place so everybody can use them on, Jet, Hera, Gaia, whatever. It also, what it does is like it'll put things in your path. So I don't know if prod util is in here, but let's do module load prod util. So prod util has things like end date and M date. So you can say like which end date, and it is listed underneath. This is an externalized version of end date that gets put in your path, and it's been created on the host system. So if we run end date, it actually is running through the Singularity. You can kind of see there's a bunch of external warnings that, or whatever, that get printed out at the same time. But at the bottom here, you can see it does end date, provides you with the answer. End date, an hour. All those things work as expected.
So Mark, I use those container modules to build my system. The system still needs a container to run.
You still need the container, but the container's already, like, you don't ever actually have to point to the container now. If you use these modules, it will it'll create that IMG environment variable and point it to the container, but you don't ever really need to know anything about it once you load these modules. And if we go to, like, if we do which CMake, CMake, this is also going to be the externalized version of CMake. So if we go back to the UFS weather model, when we make a new directory, build external, we can now build the same way we did before, but we'll build outside the container. I do want to make sure I just copy it. So. And yeah, so we're outside the container, but we're building against the container stack, and it will go through the whole build process just like it did when you were inside the container, but now you don't have to know anything about it. No. So the whole point here is like to try to show people there's different ways to build use these containers. I try to use this. I started this process because if you want to use a container with something like RT, you can't like do it remote, automatically shell into the container, build all that. You got to run it from outside. So this allows you to do things like that. You can drop this approach into with the slight modifications to like the rt.sh. You can run it, through a CI/CD system and all that, and then it basically it only takes a few changes to make that work. And then once I kind of figured that out, then that was part of where I was like, oh, okay. When you run something like the global workflow, it expects like things like end date and a bunch of other things that are in prod util or wgrip2 or whatever to just work. And so that was when I added that stuff into the module paths and everything. So when you load these modules, all that stuff is available. All the scripts though, like under prod util, are left alone. So they remain just the same script that they would be. The Python scripts also remain untouched. Python is a little bit, it's a little bit particular. You can, if you load up the Python modules externally like this, you can generally run things directly. Like if you load Python py-netcdf4 or something like that, you can run the externalized Python, and it will know how to get to import like netcdf4. But there are some other things like I run into problems with like met and met plus, where one of them, I don't remember which, is like looking for environment variables from the system, and it gets confused as to which environment whether it should be from the container or from outside. So there's some issues to be worked through on things like that, more complex Python. But in any case, like this part, this externalized approach allows you to build these things almost as if you were just on a native, just loading native compilers or native modules. It builds again using all those compilers from inside the container. So it, keeps you, for a while we couldn't get the sysadmins to update the versions of the compilers on like ISC6. So this would be an option. You can put these modules there, whatever compiler is available, through Intel's Docker site, put it up there, and you can build. You don't have to wait for sysadmins to install.
Can we treat those container modules as regular modules? Meaning we use it, build our system, and then in our registry, we just want to know that.
Yes.
We don't need to consider container now.
You could do that. The only thing that you have to do is you have to externalize. So which I'm going to show you here in a second. After it gets built, again, this executable, if I try to run it directly on the host system, it will fit.
Even we module load the exactly container modules, it still fail.
Yeah, because it was built against, it's like looking for libraries that don't exist on the host system. They all exist in the, in the container, and it doesn't know where to find them until you set it all. But as soon as this finishes, I'll show you.
Setting it all just a matter of loading relevant paths into the container, or is there more to it?
Yeah, like that was, maybe you were charging your, but when we were talking about it earlier, like you can, like, I mean, I'll show you what the, I think we looked at one of the, so if we look at the, I mean, this is the wrapper script, right? So if you set all these variables directly on the host system before you went to run, you could set all those first, and then you could do this singularity exec with this, everything you wanted, and it would run on the host system. But the idea is you put all that in a wrapper script so that you don't have to do it all. And you can basically name that wrapper script whatever you want, but like you could drop it in as just the name of whatever you're going to run. So like if you're using the global workflow, it wants everything to be named exactly what it's supposed to be named. So you put in a wrapper script in place of the actual executable, and it just runs on the host system. Do you see what I'm saying?
Yeah. I'm looking, that brings out two more questions. One of them is, so if you say you're running on a system where you don't have the old Intel Classic compiler anymore, but you do have a container, built on another system, which does have the old Intel Classic compiler, that you can still build with the old Intel Classic using the container.
Yes.
And then run on the new system, which doesn't have the Intel Classic environment, because the Intel Classic is in the container. Of course, that's never going to be used here.
So here we have the UFS model. If we try to run it here, I mean, it's not in a place that it would run anyway, but it's built against the container. It won't run because it doesn't know, where all the libraries are. I've added this extra, it's basically a slightly modified version of that externalize command, and it's called make external. And what it'll do, you just give it just the name or names of whatever you want to be externalized. And what it does is it makes a wrapper file, a wrapper script for it. But in this case, whereas before it was putting the wrapper script in a different directory, this script moves it creates a backup first of like, so in this case I did UFS model. And so now if you look here, there's a UFS model.orig. So that's the actual binary file. You can see it's a lot bigger. The UFS model is now a wrapper script, and it's a much smaller wrapper script. And I'll tell you why in a second. And then there's it basically has moved the original UFS model into something just .UFS model. So that's this .UFS model is the original binary. So
what's the Docker version? What is .UFS model?
So what I did, the reason I did this was because, again, like when you're running, like if you're using the global workflow in particular, after you build, if you build everything, you've got these executables and then you link them. They're all in like global workflow /exec, right? If you could, initially my approach was move exec to something else, container-exec, and then externalize everything in the container-exec and put it in exec, right? So that you have wrapper scripts in exec, so that when you run the global workflow, it finds the executables or the scripts, the wrappers, where it thinks they're going to be. This way, you don't have to do all that rigmarole. You can just externalize everything in a directory that you want to, and it'll create wrappers for everything. And this script is smart enough to know, like, don't only do it to ELF binaries. So like it will look, and if it's an ELF binary, it will create a wrapper script for it. If it's not, it just leaves it alone. So if it's a Python script or it's a shell script, it just leaves it. So this one is a little bit more sophisticated, and it should, I think it just helps with, it helps with, you know, like integrating into various, you know, NOAA work, yeah, existing workflows and things. So here, if we try to run it, the externalized one, and I mean, that make external command, like when I've been working with this, it's like one of those things that I always forget to do, because I'll build it and then I start trying to run it and I'm like, it doesn't work. I'm like, what went wrong? And it takes me a couple cycles to, you know, come to the conclusion, all right, I forgot to externalize it. So yeah, it runs the same. There's another difference to this that I want to explain as well. So let's go back and look at that.
So is make external a different version of externalize.sh, or you have to do both?
You just have to do one. The make external you can run, the make external is designed to run from outside the container. The externalize.sh is meant to be run from inside the container. And so when you run the externalize.sh inside the container, you should have all the modules loaded that you need to run whatever. So like if you've built it in the past but didn't externalize it, and then you just shelled in and ran that externalize, it won't get all of the paths right. You got to load those modules first. Similarly, when you use the make external from outside the container, you need to have loaded the external modules first. So it actually is expecting. So like this is the wrapper script for the UFS model, and you can see it's like it all fits on the screen. It doesn't fill in all kinds of extra stuff, because that extra stuff is filled in by the modules. So like if I do a module list here, you can see I got all those modules loaded. If I do an echo of is it Singularity NV on this one? Singularity V. Geez. All that's the LD library path that gets fed into the.
And that was created with the convert modules.
No, this is from the when you load the modules externally. Like it sets it as Singularity ENV blah blah blah. So you got to load the modules if you're going to run it. And this is the same way it would be if you built like, you know, if you built the weather model with native modules and you didn't load them before you went to run it, it wouldn't be able to find, you know, things. So so that's the main difference between those two. So you do have to load the modules if you're going to run this using this approach, the externalized modules, but everything else, you know, the approach is generally the same, just slight nuance differences. So let's see. Do we have any other questions about that, or does that kind of make sense to people?
Could you post it the other way that you run the externalize? Because I think this.
So it's just called make external, and I can show you what it looks like. If we do which make dash external, it's placed in your path when you load stack intel, and this is what it does. Is it basically takes all the arguments you pass it. So if you pass it a wildcard, it'll look through everything. It basically will go through each file, check to see if it's, is this file, is it an ELF binary? If it is, then it will run through this. This is slightly different version of externalize.sh, but it does it all through Singularity exec. It creates what you need to, all the things that it does. So I guess with that, let's see what we're going to do.
Is the command that you just run, is it in the slides?
Yes, it's here. Sorry, I got ahead of myself on the slide. So, or, like if we come to whatever page this is, kind of explains how we externalize it. So that make dash external.
Mm-hmm. Okay. Thank you.
Okay, so the convert modules is a tool that I developed you really should only have, like, most people, if you're using stuff on the RDHPCS systems, you should never have to run it, because we'll already have done it and put it all in one place. If you're going to run it on, you want to, put this on your desktop or, some academic system that, is not affiliated with NOAA or whatever, then that's where you want to run the convert modules to create everything. And so it is, the thing is like, it will create pretty much the same thing that I have created, but there are, like some of the paths in there, like it actually puts in your path, like end date, the externalized wrapper for end date and all that. And that has a host specific path to it. So it does all this grepping and, whatever combo, whatever stuff that it has to do to get the actual path on your host system for things. There's a couple other pieces to it that, like, module paths also have to be set on the host path versus the container path. And I mean, if you look at the convert modules script, it's a lot of bash and some Python. So I'm sure it could be written better. I was just putting it together as I went along. So
yeah, this way, the expert in container, I will feel not confident because it seems too invasive, aggressive, like to change the file to another name.
I figured that people would have different comfort levels with, and that's why I wanted to show people how to do things, either shell into the container, build it that way, or use the external modules. So like, and we need the external modules for sure to do things like RT. So, like that was why I developed them. And then
how hard is it to write the external modules on a new system?
Not hard. It takes, when you run that convert modules, it will basically copies them out of the container. Mm-hmm. It changes a bunch of paths. And then externalizes a bunch of executables that are in Spack-Stack, like wgrip2 and end date and m date and all and other things. NC dump, for example, like under netcdf. Mm-hmm. So you could just run that on the host system and it'll all work, even though it's a containerized version. So it takes, so when you run it on, assuming your file system is pretty fast, it will complete in like 5 minutes or something like that as it goes through and does everything. And, Sam was running into problems when he tried to run it on Jet, which I ran into also, that you have to, sometimes the bind directory gets a little messed up, but
5 minutes. So it's not just setting up alternate environment variables. It's doing something to the executables.
It's doing any of the executables that are in Spack-Stack, mm-hmm. it creates a wrapper for and externalizes them.
Okay.
So that you can just run them on the host system as if they were, native.
How many executables is it actually processing? Tens of thousands? Or?
No, hundreds, I guess. It's not, because most of those modules don't have a binary. Like basically what I do in that script, the Python script, is it goes through and looks to see, is this module file, this Lua file, does it prepend your path? If it doesn't prepend your path, then there's no executables that are involved in that module. So, maybe like SP or CRTM don't have any executables and that sort of thing, but others do. All right, so now we've done this, we can try the global workflow, which is the last thing I was going to do.
When I try to use your modules,
It's in the cloud shared again.
it's not finding iForce. And I looked in here for Intel. It doesn't exist. Also, the particular version of Intel you're using here doesn't exist on Jet.
Well, I know it shouldn't exist on Jet. That's the container version.
Right.
And I don't think I externalized the compilers directly. You probably could, but
when I try to compile this way, it doesn't find iForce.
Did you use, or what are you trying to do to compile it?
I'm trying to follow this, which seems to be telling me to compile outside.
Yes, yes, that's correct. So when did it run through CMake?
CMake couldn't find iForce. Tried to use the GNU compilers. I can't remember the exact.
So did you externalize the
Oh, those are the, I can do it again for modules. Slide.
Mark, may I ask a question?
Sure.
Yeah, so I understand that you build one version of Spack-Stack package on containers, and we can probably use on all the other platform, Jet or Gaia. My question is, so when we externalize those libraries, and then when we run the model on those different platforms, we still have, say, different Intel compiler, different versions. Will that from the native platform, or it will also externalized by your container?
Yeah, it will use the container compilers. So when you run CMake or EC-build, it will find the container compilers and use those to build everything. So it doesn't rely on any kind of compilers on the local system. The only thing that it needs on the local system is SRun or Intel MPI. Yeah, so it should be more or less. Although I mean, I think we've seen now that like it may not be binarily, exact if you build it on like it looks like on a newer system versus an older system, because like the compilers still can see they can still see the CPU, and they can optimize accordingly. So if you're building on, like if you built on a newer system and then you try to move that over to an older system, it might not work.
Okay. Yeah, that's my question. So if that's the case, can we expect exactly the same baseline on all the platforms?
Yeah, I guess that it probably won't be exactly the same.
Okay.
It's interesting. I hadn't considered that, but yeah, it seems to be the case.
Okay, thank you.
Mark, it's giving me I don't see how this could possibly work without the build system knowing where the compiler is.
Well, when CMake runs, it knows. So I think it does. I mean, I just showed it working. So
what am I doing wrong?
I think that it may be.
Oh, I did do it with yours.
Can you do it one thing at a time so we can see what's going on?
the current shell. The ongoing reviews. Stack until. No, oh, geez. Try it again.
You can do both of them all together. Okay, and where are you? Yeah, you're in the middle of stuff.
Nope. I don't usually use Windows.
I hear you.
Okay, is anything wrong on this line?
That looks good.
So now it works.
You probably, like, maybe you had the multiple, I don't know how you were doing it there before, but it may have had multiple module use or something was not quite right, but. So, and you can see, like, when it finds these things, like, they're in opt, right? So that's where all those things are, it's pulling from. So yeah, what I'm doing right now is I'm cloning the global workflow. So this will be just an example of how you can build and run this. This is, again, like, if you're going to run this, you're going to run it on a machine that's already been configured, pre-configured to run the global workflow. So it's Gaia C6. It means the data is already there. There are things involved in the global workflow that will recognize that it's on Gaia C6 and be able to find things. But we're going to build the executables that are going to run with the container. And I'll show you how to link them, and then, you can set up an experiment and run it. Yeah, I don't know. I don't think I've seen that before. It doesn't seem to be super important for some reason, but
it stops the download.
I think, not sure which one it is. I think it's one of the packages that we're not really building. So, oh, right. And this was the other thing. So in order to get this to work, I put together a patch. So we're going to download or clone that too. Git clone.
What's that?
I'll show you. This basically adds all those things that, like the little scripts that are, detect machine and module setup and various other little bits that are hard coded in the global workflow to figure out where it is. And this patch, when I untar it, I'll show you what some of the files are. So. It's really annoying that I can't see that down there. So this is the list of files that I'm just untarring it. It's not really a patch, so I'm calling it that, but so it adds some of these files so that you can set the machine ID to be containerized, and it will know where to load everything. So that's the vast majority of what these things are. There's a few other things that need to be changed. And here's a machine setup that needs some different things to it. And we also have a Spack version and a build containerized version for the version numbers. So So that's until that patch, and now we got some things to export here. I set up this container module path. So it's in the module files and module container base. So if you look here, no, I think maybe it's in this, let's see, version of this. Yeah, it sets like the SPAC module path equal to this container module path. So that's what we're going to do. Export container module path. And we're going to do this in the world shared instead of project shared. Other things, these are just sort of some of the things you got to do to get the global workflow to run. So we got export the home GFS.
Your source
Yeah,
failed.
I got two sources though. That's because I typed it twice. I don't know why, but okay, there we go. And then you can use these modules and just to test that everything got set up right. We're going to module use this, the global workflow modules. Then we'll module load, build. No, that's module base. That's what it is. Jeez. Is that right? Okay, so looks like everything is getting loaded correctly. Again, these are all externalized modules, end date and all that stuff. They're still in the environment. We're going to go into the source. We're going to do build all GFS and let it build. That'll take a little while, which maybe is a good time to take a break. And reconvene in maybe 10 minutes at 3:05 Eastern. And then we'll go through the rest of getting it to run and go through any questions, I guess.
Right, be able to build a huge script that would work because it sends it to S batch and builds on it.
Yeah, these are the things that there's a ton of those things that
Yeah,
will not
he's
work out
kinda
of the
started
right.
that whole list of things
Mhm.
and tell it what machine it's on.
Yeah.
Start.
Yeah,
We'll have to incorporate that everywhere like we do go to any other.
yeah, and that's what I'm hoping is that we can get some, groundswell to get this approach set up as if it was like a new machine. Yeah.
Once that's done. it's anyway.
Exactly. And then I'm also hopeful that I think this is a good opportunity for us at NOAA to reconsider the architecture and the separation between instead of, like having everything defined by machine,
Oh, God.
but we could have a platform that is, but then the data could be separated. So instead of it being tied to the machine, under the machine, you say, well, whatever, the fixed files are here, and you've got an environment variable, but
Because we start using machine ID in all these various places and it's not tracked. And it's
Yeah.
anyway.
Yeah. So
when you go to a port, you have to go through everywhere that's done and reconstruct whatever it is that you did there.
So it would be maybe a good time for us to start thinking about how to separate some of that so that data is all identified by environment variable, and then each machine, you could set those environment variables for that specific place, but you'll do it all in one place, so, and
then you just have to publish the one place.
yes, right. You could even make it a Git submodule that gets pulled in by everybody. Yeah, right. So anyway, I'll be back in 2 minutes and we'll move on.
Yeah, I don't think I can run it today. I just think it's.
Does anyone else go load the modules, please?
Mark, may I ask a question?
Sure.
So on the UFS web model side, once we have the module files, you build, say in the future EPIC team, built and externalized on the platform, then on the UFS weather model side, the developers, they will only see the module locations. They actually do not care about where the container spec stack is built. They can directly use the externalized module files, right?
Yes, yes.
Okay.
Yeah, I mean, I think it's helpful to recognize, for developers to recognize that it is containerized.
Yeah.
So they remember that they have to externalize any executable, but for the most part, they won't have to know it, like they won't have to know the path to it. Once they load the module, the stack intel module, it takes care of where the image is and everything. You never really have to look at it as a developer.
Yeah, one question on slide 30, let me see, 37, and build UFS weather model externally. You mentioned after we build, say I'm on Gaia, I was using externally built containerized Spack-Stack. So the last line, do we need to do externalize and then make external UFS weather model?
Yes, you do. So after you build it, that make external, if you don't run that make external on it, and you try to run it from the host, it'll have all these, like even if you just did LDD of that, you'll see like all kinds of things that it doesn't know where they are. After you run the make external on it, it generates a wrapper. It generates the wrapper, and it leaves, well, I mean, it makes that wrapper called UFS model. And if you open it after you run that make external, it'll just be a little script. It moves the actual executable to .UFS_model.
So from user point of view, say we have the module files point to the container built library, and then the only change we need to make to the currently what we have been doing is that we do need the two lines, either externalize or make external. Okay.
Yes, exactly. That's the one thing that needs to be added to like RT.sh is a little line that says, but probably, like if building as container or if containerized, then make external, and that's it. Yeah.
Okay.
I was on module load, module based containerized, and I got a warning saying, has too many containers module files, has too many non-module files.
Maybe.
I think it's that base container.
Before I did with module purge, and then I use module load, module based containerized.
Yeah.
Let me see if I get a module list. I mean, yeah, it's giving me a long list of modules, but it's not where I work.
Let's see.
I'm trying to do it like.
You have the same problem?
Yeah. So I was steps. I went into one. I went to okay.
Did you put the path that
I'm sorry.
Yeah, okay, that was good. So let's just do it. Oh,
Sure.
Mine was kind of none.
Jay said I was first.
And then modeling use.
Oh, you have to source the version file.
Yeah, you do have a source version file. So that gives you all the
Right.
particular
Otherwise you get
versions.
none.
Yeah.
Is that in your slide?
Is it? I don't remember.
I think it's left out.
It's in there, but it,
Yeah, it has an open source source.
Yep.
yes, that would cause problems.
That would cause problems.
Source.
Oh, hold on.
Mark, you may want to fix this error in your slide before.
Yeah.
Oh, yeah, that's it. Source.
Source is the problem?
Yep.
Source.
Don't realize the moment it happened to you.
Right. Source.
Where is it?
Oh, so your build all.sh should probably have // before it.
Yes, that's true.
Is this presentation itself readily findable so I can look at it later?
Should be. I shared it and it should be in the, you should, and if not, I can always send it to you. And this is all recorded, so. Not that, we'll see how well that works for everybody, but. Still building. I think the weather model's still building here. Did it work for you then? It is, or it's underway.
Working.
Okay.
It'll take its time. I got past that by taking out one source.
One source, okay.
So on slide 35, you can edit the C6 to.
Okay, let me do that.
That was the top one. That would be it.
Which, I don't see the page numbers on mine, so I'm gonna,
It was, let's try using this line. That one, the C6 line is when the project shared.
should be shared. And that doesn't fit, but okay. Yeah, thanks. Then it'll help other people. Get out of this container.
Oh.
UFS, GFS. Oh, 1 second here, we're done. Yeah, okay. All right, so everything built, at least for the GFS, it's not that much stuff, but so one of the things that we're going to do here now, just to get this to work and run a simple experiment with the global workflow. Usually I have to link the workflow. In this case, what I'm going to do is I'm going to change my machine ID to, I think it has to be capitalized. Let's see. And then run the link workflow. So this basically, it identifies we're on Gaia C6. No, it's not that one. I guess it's the little one. And gets our fix files and everything, in addition to putting a bunch of stuff in exec here, right? So we got a whole bunch of things in exec. They actually are, as you can see, soft links, but the make external will handle that just fine. And we can do, I usually try to put the full path, but I don't think you have to. So to give the star or wildcard, it will go through and externalize all of the executables that are in there. It skips over any of the scripts and just leaves them in if they were a script in there to begin with. So now if we did an ls exec, you'll see there are, it actually puts these things way down in those, like the full path of it. So there'll be this, and there'll be an ridge, and there'll be a dot Gaussian, right? So this one is now a wrapper script. So so now when you go through the global workflow, if you're going to try to set up everything, and it's going to look in exec for the executable that it wants to run. It's going to find the wrapper. It won't know any different because that will run on the host system.
And you better do this in the next few days because it's all going to change.
Right. Well, it should still work. It's been working.
We're allowed to do it from the same branch, but the developed branch is going to change.
I think unless if you may have to, if the executables are put in a different place, you have to do it.
Someone
Yeah.
changes machine ID in another place somewhere, it will stop it.
Yeah.
You can't maintain this patch.
No, that's what the hope is, that
Yes.
EMC and others will help convert.
Convert and standardize.
Yes, that's the idea. All right, so this is what I found to be the best way if you're on a machine that you don't, rather than install a whole bunch of stuff and use externalized Python and all that, I find it easier to just create a virtual environment and add the things that you need to generate your experiment and run it, and then you're good to go.
Sorry, can I use Conda?
If you could try, it should work just the same. I mean, there's another step later that you're gonna have to go through to, like I'm doing source, home, VNV, blah, 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 activate. You'll do conda activate, I guess would be that. I'll show you where that goes.
Are there any machines where PIP is not supported besides WCOS2?
Yeah, see, like that's probably some, but not, I mean, PIP is really, I guess the issue is if you were not, if you were like on some machine that had no access to the internet, you'd have to come up with some other way to do this, but.
It's on there, it's just not supposed to use it.
There you go.
Why is it on there?
So I had this installed before, but I'm going to remove that.
I was using it, I didn't want to load. Had to start over.
Might have to do Python 3.
So PIP is supported on Hera and Jet and Gaius and both Gaius.
Yep.
Hercules.
Yeah.
And Ursa.
Pretty much
and
everywhere.
Orion, but not WCOS2.
or you're not supposed to use it, as Terry
Yeah,
says.
that's actually worse because if you use it, you caught, you get fired. So.
Yeah, so stuff.
It probably won't first. Oh, I remember. In some places you do have like this. There's this upgrade as or Python. Let's see. Python. God, I can't see this stuff. -M. Installed FFRN. Okay. Good. Type it on the right. Copy it again. So yeah, and basically there may be some more Python modules that you need for some of the more advanced things, but this will handle some of the simplest.
So I think what my mistake is, what machine does your version support?
What do you mean
When you source the version number, it might depend on the machine. Because I have, everything works great, but it looks like it says, don't have this, don't have that, because the numbers don't match.
The versions should all match the versions that are available inside the container.
You're getting failures here.
Yes.
Oh, right, because I'm building against the containerized.
Right.
Didn't load that,
Right.
okay. Right, because okay. Oh, no, I have module purge and then load module base container. And then I have the unknowns, even though the version number is correct.
I think you might have to go through the steps again, maybe.
I'm gonna look, see if the module-based containerized the modules direct.
I don't know why it's going on with that. Maybe we got to do this.
Could not build wheels.
I'm going to go out. We'll try running that again. So let's see. Source. Let's do one at a time. Maybe we'll start with the other ones first. Oh, I guess I have a netcdf for it in there twice. It's part of the problem.
Right, so when I do modules avail, I see all of my modules that are supported by my container. But then when I do the module load for the containerized modules, I have some that are not the right version. Even my source version.
Do you do module purge first?
Yes. When you have a moment, we'll do the steps one at a time. I'm going to do it a few times myself and see if maybe it is a version problem.
Okay.
Because it's only a few that didn't come up. You know, there's a lot that it loads, and only some are by their version numbers.
Okay, so I think this all got installed correctly here. Although we had some initial errors. So before you go to set up anything, I do like to change the defaults so that I don't run through 120 hours. Farm, what was it? Dev farm. So let's make this already do it? Yeah, okay, here we go. You're not going to do the tracker or the Genesis or the Met Plus. So I'm turning all that off. Okay. Okay, so then there are some things to change in this host file. Again, we're going to leave this so that it knows we're running on Gaia C6 because it knows where all the data is and it has all the configuration set up for C6. I think this is the right directory, but I'm not sure. Let me see. Yeah, it looks like that'll work. And all right. Yeah, I usually do this setting up a new experiment. I have temp set up to be, a particular place. So when I set up the experiment, do the setup experiment. And here what we're going to do is we're setting up a forecast only experiment, GFS, it's C48 resolution, telling, the workflow, where to put everything, the dates to start and stop, and hopefully this will work. That looks good. Now, this almost never works for me the first time, but we'll see what happens. I think, yeah, I've got to unset a bunch of variables for some reason. All right, so now we have the experiment set up. We can change to stemp, exp-dir, and we should, I know one other thing we got to do. And see, like if I knew how global workflow worked a little bit better, I'm sure I could have gotten this figured out to begin with, but the account is not EPIC. It is Bill Fire.
Yeah, you just created, you can now create a dot file in your home directory. It'll pick those up. You just added it.
Okay, that's good. Oh wait, you're just gonna run Rakoto run.
Because there's that in stemp. You also put that in there.
And this is another thing.
It's like a user override for those.
So.
And they're in the develop branch now.
Okay, good. Yeah, so it's submitted the job. I don't know how that's going to take to run, but hopefully it all works correctly in the first time. These are the things where, though, you definitely can get it to work through all the steps, or at least these simple cases. If you're going to try to add Met Plus, I think the best approach is going to be to install Met Plus natively on machine.
Support drop-off.
So there's some other, you can build the GSI, so the GSI will run containerized version. The EPP runs fine. The wcrypt2 runs fine. It'll all run through the workflow. These things get set up. Oh, I know, I did forget to do some things. Let's see. And I had to see if I followed through on my script or my, so I bet you anything that this will not work to begin with. We'll have to reconfigure it. So this is where you were talking about using Conda. One of the places that needs to be, what I find is I'm going to copy the module-based containerized to, like if you're running on Jet, you're going to make it module-based Jet Lua. And then also the versions, and then we're going to edit the run version. So if we do copy, so what this does is just
right. There's a build version and a run version. Is really
And this way, when it goes through the workflow, go through it, say, I'm on Gaia C6, load these modules, and when you copy, it'll load the containerized modules.
Right.
And then in the versions, we're going to do the same thing. So copy, build containerized version to build Gaia C6, and copy run containerized version to run guys.
I think the current step, but I don't think maybe you can help me with the.
Yeah, maybe. So then in the run version, we're going to do this. We're going to add a few lines. So what I would like to do is set the module file up when I do that convert modules so that it actually sets fsync to be fsync file and end date to be end date and everything. So you load throttle util and it sets those variables correctly. Right now it's not quite right. So you got to set them explicitly, and we add that to this run run.version, which gets executed early on in any of those steps. So I think, oh yeah, and then there's this other piece. Some machines require that --PMI, MPI equals what are we looking at here? These are the ones that are all caps. Okay, any place that has srun in it, if it doesn't have the, you might have to add this --MPI equals PMI2 to get it to run.
Yeah, we had to go patches for that. We couldn't figure it out.
Yeah, so, and you might have to, you know, like, I think srun is used a couple places, you know, for the launcher prep also, so adding it in. Although I found like on Ursa and now on Hera, you don't have to add that extra flag, it just runs. So it must be set by default to go to PMI2. But yeah, on some, like on Gaia, you have to add it explicitly. So that's what gets those MPI libraries connected to each other, so everything runs. So let's see if it's still pending, so I don't know.
That's the drawback. There's so many particulars like that, variance between machines, and then we don't have a consistent way to get the runners.
Yeah.
Then we set a class for that.
So, yeah, really.
What does PMI2 actually do?
Well, so
just saying.
--MPI PMI2 tells srun to use the PMI2 libraries to do the communications.
That's one just another big record.
But yeah, I think it is. And there's different, you could use PMI, and then I think there's a couple other possible libraries or approaches that it can use. So anyway, I think that's the summary of, and we can wait for this to run, but
I have a version misalignment, and I'm pretty sure I got all your slides. Give a moment, just.
Yeah, I'll come over and take a look at it.
I'll show you exactly that I ran every one.
So yeah, that's basically the workshop. And you know, if you have questions, certainly you can contact us. I think we're going to try to you know, open this issues page under the NOAA EPIC UFS containers issues under GitHub for issues that, you know, come up about this if you're trying to use it.
And I think I want to go through all this as an exercise
at your own pace.
At my own pace. I'm not able, I wasn't able to keep up with all the issues I had.
Mark, when you get a chance, I'm wondering why it can't.
Oh, okay. So did you change your machine ID back to Gaia C6?
I'm Sam.
They're not on Gaia C6.
Oh, okay. We'll change it to Jet then.
Oh. I didn't see that in instructions.
Yeah, I may have not have put it in there. So I think what that link workflow is doing, one of the things it does a bunch of things, but one of the things it does is it look for, oh, I'm on this machine, the fixed files are over here, link them into wherever it needs to be.
You wanted me to put Jet where it said pre-configured machine?
Yeah.
Okay. I see.
You're saying? What can work? So the first one is to get the path right to the containerized module files. And that we got in this one, right?
Oh, yeah. That's just what I put in there.
Well, no, it's my path.
Okay.
It's not mine. See, you know what I'm saying? But this LS it, right? So LS. Dollar image.
Yeah, just not a pre-configured machine.
Mark, another question for you.
Yeah.
So on slide 37, you have, I'm building the model using the externalized library. So the tool command externalize IT dash, is that a command?
I can go.
I have.
Oh, this one, machine ID, containerize, that was one.
So there are two lines at the bottom slide 37. So after I build the model, I need to run externalize
You don't
IT dash.
you don't have to write. Yeah, externalize it that's a comment. Sorry.
Oh, okay. So I just need to run make external.
Yes.
And then after that, make external. So go back to slide 32. I will run the test case. So I just run is that srun, and then the external UFS model would be the one I just created from make external. Is that correct?
Yes, that's right.
Okay,
And
thank you.
you might have to add some extra things to that srun, to get it.
Yeah.
But you copy that executable. No, that's really it's here. You're gonna have to, but you're loading this one. Yes, that's correct.
Yeah, that's good. That's the container path, right? So,
And
I was
then
to use it.
What's the next step? Oh, here it is.
You got the home GFS.
You got this, right?
And that's.
Here's
Yeah, that's good. You got, your machine ID is.
oh yeah, right. Containerized. That's the real juice, right? And source version. Right. That's where we get source. Right. And you fix the slide. Source. Module. And we did the module first. We can still do that.
Yeah, you could do that.
We haven't done anything yet that we want to do that now, right?
Yeah, I mean, you might want to do it after as well, but we'll just,
Okay.
what module we use now.
But right, because we're doing it right. And it's now that use. And we're using here.
Yeah, you got to do the module file.
What? And then load them, right?
I think, yeah. And this is where, yeah, it is test to see that you don't really have to load them before you build it, but this tells you.
Yes, and that's where I was getting some of the missing ones. Finding that, right? It's in the model use. Ooh. I think it's minus touch. It works. Oh, that's where it was. See, that's why I'm saying when my versions are wrong.
Okay, do module purge and then do another module.
Sure. That's easier.
Yeah, I know. Okay, what's your image again? Okay, what that picture is.
Good building. Is there something we need to do to the,
Oh, you're using, did you create an image or you copied it?
I copied
From where?
from us?
Yes. I wonder if they.
Look at my history. No, I did it. did it.
Do an MD5 sum on your image, just
Oh,
MD5
because you
sum.
don't remember.
I know what the last
Right.
3 things are. MD5 sum, just no space.
Oh, right, that makes sense now. First, we need to get rid of.
Yeah. And unfortunately, yeah, I had to update that image all over the place just to make sure it was all right. But there are still.
So it was someone else using the IS6.
What's that?
Is this, would this mismatch only happen on C6?
It could happen if you just got an older version of the.
Image file, okay. Yeah, but I mean, it's failed clean, you know what I mean? It's a nice clean fail. There it is. So you should use a wget one.
Well, if you do that, then you gotta convert the modules or things.
No, you still, oh. We just did that. I didn't put these back on. Where is, was it?
Okay, that is the right one. Yeah, I remember. It's an E, so, let's see what we just look at your conversions and then that.
I started doing that, yes, cat the versions. How about a module list, huh?
Or module avail.
Yeah, I noticed the avail, because we did the load, right? Was convoluted with all the ones that we already had, so it's, oh, it is. Oh, look, that's just that one. I'm trying to put that.
You could do mod show, mod is based.
Oh, see, now you see the versions, and let's do this thing that's like, right? So, do this.
Which one? Yeah, let's say. I have a feeling what may be happening is you got some other thing in your module path that it's trying to load first.
Purge isn't enough. Is the
Yeah.
other thing saying unused everything? Is there a more advanced, higher purge? Yes, reset. Then you go on the second one. I'm sure that's it. Because it's picking up the ones I already have. See?
So you do a module reset and then,
Yeah.
so you, well, you might have, now you might have, probably don't have anything in your path, or do you?
Oh.
Think that, I mean, if you do module avail, you probably have nothing. Right. So.
Right, that's good. That's what I just cleared. Right?
Yeah.
Now, this is. Oh, it helps if you spell it. Right?
Hope so. Yep. It does take a while because
That's a good sign. But that's something else, right? See, it's a particular one this time now.
Batteries about to die.
So close. Okay, you got me close enough. Mark, I'm sure I'll figure it out.
I think it's probably your. I don't know, like the. You may have to go through the whole thing.
I'll start
on a fresh.
I'm starting from the third.
There.
Yeah, I just, so I did module use.
Mm-hmm.
It is module purge. And then when I load the module based containerize, I got this one. And then, but anyway, the thing didn't work because when I went to field, says,
Yeah, it looks like it. If you can't load the modules right, then it won't.
yeah.
Right.
Well, this is a warning, so I think if I do a module this, I mean, I don't know if this is supposed to have that issue.
It looks like module based container.
Yeah,
And where are you? You're on guys 6.
yes, and then when I go to build.
Yeah, if, well, let's see.
It says, no, it doesn't work. This is a non-platform status expected.
That's okay. The unknown is fine.
And then it fails, the build fails. Well, or it goes fail.
Maybe it's, that's a good sign because usually if it's the modules don't load right, then it fails pretty early. Maybe when you reloaded it or something. The modules are a little touchy. They normally you'd set up those little modules so that they would you could put in like a depends on. So it will go through and look, you know, like if you load like NetCDF Fortran, you can in that usually in that Lua file it'll say it depends on NetCDF-C and HDF5 and something else. But if the Lua, that's the or LMOD, see the LMOD or installation on the host machine doesn't match the container, that gets messed up. So I had to change all those depends on to below.
See, it's failing. It's failing.
Yeah, it is
now.
going now. So let's see what it looks like in the logs. You can get the logs and then just so there's a logs directory right there.
Okay, is this just give months?
There's
It's a
Linux
leader,
directory,
they were-
yeah. Just look at one home. They're probably all similar reasons.
Somebody online is.
Somebody online is better question.
Hi, actually, I have a question. Can you hear me?
Yeah.
Yeah, I have a question. If I use the container and if I need to install the new packages, how can I preserve that for the next time? Because if I come out, whether I need to redo the same step again?
If you're logged into the container,
Yeah, if I adding new packages to the container to install new packages, something like Metis or something, other dependency files. So if I need to do again for execution of the whether for UFS compiling, so do I need to repeat again same steps every time, or that I can keep a new image container as duplicate with the new package files?
I mean, if you wanted to add things to the container, you're going to have to, and you want it to be in the container, you're going to have to turn it into a sandbox.
Okay.
And then you're going to add new packages, and then you're probably going to want to reconvert it back into a SIP image.
Okay.
And then it'll be saved in that new image that you
New
have.
image. Okay. Yeah. Thank you.
But the real way, the right way to do it is to change the Docker file.
Yeah,
You build it in, otherwise if you keep doing that, it will grow.
Right.
Then if you do it several times,
Trying to do something else.
So you're in the container right now.
Oh no, I just did an LS. This is what I'm running. This is external. I'm not talking about space.
Oh.
No, this is just I wanted to.
Oh, it's different. It looks like it's the same.
I'm sorry, yeah, I just wanted to. This. I mean, that looks right, right?
Yeah.
I think I just have to repeat this.
Hopefully, that's straight it out. And,
Yeah, I mean, you gotta go over.
yeah, if you
figured out
if you try, just email me.
Thank you.
Sure.
Hi, Mark, can you hear me?
Yes.
I have a question. When I try to compile UFS externally, the CMake tools cannot find the NetCDF library. I'm on S4. Is there any issue with this?
Oh, you're on S4. Okay.
Yeah.
Did I don't know if, did I build I'm not sure I externalized the modules on S4. That'd be the problem.
Okay.
So I can do that real quick. Let's see.
We get underneath you to get our.
Oh, yeah, sorry. Yeah.
All right, let's see. What do we call it? Stack 1.6.0.
My evaluation is that it is very promising that you need beta testers.
For sure, for sure. And I haven't really had any, so congratulations. You're now a beta tester.
I think with more refinement, we won't have as much problem with adoption as we typically do with new technologies. Because it's pretty straightforward extension of what we've been doing.
That's what I was trying to make it as similar as possible, but also allow people to to shell in, because I know some people are just gonna be like, I understand, that makes more sense for me. It's like SSHing into a new machine, whereas but also using the external modules, I think, helps make it a little less complicated, but it depends on how you view it all. Yeah, I think hopefully people can work on it together. That was part of what I wanted the people to do in the workshop, was just to get familiar with building some simple stuff with a container. And because I think a lot of people have never shelled into a container before, and or tried to bind a local directory. So I think understanding how some of that stuff works just as the basic level will help the rest of this work as well, hopefully. So.
Mark, have you got your work with the progression test system somewhere that I can take a look at? Or
I'll have to look it up, but yeah, I did get into it. I had to make basically just like
too many changes.
like June was saying, there's the someplace in that compile, I think the compile.sh, you add make external to it, and then that, yeah, it pretty much handles everything, and obviously you have to add those, change the detect machine stuff a little bit, and the other little things to make sure that it doesn't just fail because it doesn't know where it is or whatever. So yeah, absolutely. I'll look it up and send you a link to it. So cool. Thanks. Yes.
Yeah, I have a question curious here. For example, education, for UFS, we have a container. But then for JIT, we will have another. So I think
yeah, you could. So this is that's a one approach to containers. You could. There's so many ways you can use them, right? You can
What's the best way to recommend?
So I can't say that there's a best way, you know, I mean, the way that I kind of designed these was to, like I mentioned at the beginning, was to try to make, when you shell into it, to look like you're on a Hera or something. And so you can just use the Spack-Stack, the whole thing. And you have all the, you know, you can make these containers like super stripped down so they have almost no extra Linux commands in it.
Less container will be better. But for such HPC, if there are only one user of HPC have desk, have a environment for UFS, or all of us can do that. Then in that case, we need to do it by ourselves. So yeah. How can we make use of next one?
Yeah, I guess it's worth thinking about to try to figure out what's the best way.
I do so much.
I usually use,
I don't think this works.
Sonnet.
Oh, I know.
So this came out and it means that we first make sure to understand what it's had every week, come up with a plan.
Well, I usually wind up, make sure that I, well, versus.
So then I adapt the results of that. Make sure right, so that has the script, you know, and we get before you react, join the I saw you. Started. This project. Maybe see if we can have it. And actually died. Something and actually. Great. And then I saw. I have cases. Just conversion on.
Mark, can I ask a question?
Sure.
Yeah, I try to run the executable external rise, so using the make external. So I build and looks like everything is built okay. And when I run the test case, the C48 test case, that is working with the when I build with container, right? Now I got an error message. I put in the
the chat.
Yeah, it complained about ESMF initialized. Do you have any idea?
Yeah. I don't know. Let me bring it up. Isn't that,
I need to figure out how to run.
Oh, okay.
yeah. I'm not sure why I don't have my. I can't find my window, June. Hold on a second.
Okay.
I'm sorry.
Here we go. I'm gonna unshare my screen too, so I don't have to see that anymore.
Everything else works.
Yeah, so it sounds like.
Do you have?
I know this is amazing.
Do you have your modules loaded before you ran S?
So I
and
I just followed the slide 32.
okay, so you're running from the same terminal screen or whatever that you built it from?
Yeah.
Okay, so and are you in the UFS warm start 1 directory?
Yeah. So after
Okay.
slide 37, then I follow, I go back to slide 32 to run the S run.
Oh, actually, you can go from here to.
Loading system.
Yeah. Okay.
Okay, nice meeting you. Okay, Mark, thanks a lot.
All right.
Yeah, see you.
Thanks for coming.
So I'm working on it. Sure. You know, how to get back.
So, okay, you're doing S run. And in this case, you're not using the build under / extern, you're using like the build - external
Yeah.
UFS model.
Mhm.
Does the other one work with the build / extern?
Yeah, before it was working.
And then you'll see how it's done.
And so
Then the only difference is now I use this build library and then using make external.
So maybe open up, well, it seems, yeah, open up the UFS model wrapper script that's in build / external and see what it looks like.
Okay.
You can share your screen if you want, and then I can take a look at it.
Oh, let me see.
Thank you, Mark. That was very helpful.
I'm glad it helped some people understand
Yeah,
what's.
no, it's good what you're trying to do and.
That looks pretty good. I wonder if you might try where, like that, the last line where it says singularity exec -B, I wonder if it might help to add this /LFS5 there after MNT.
Okay. Mhm.
Just see if it helps.
I have to go, but keep up the good work.
All right, thanks, Sam.
Good seeing you, Sam. Do you live here or did you travel?
Wheaton.
Uh-huh.
Yeah, I flew all the way here from Wheaton, Maryland. Yes, I show up once or twice a year for something or other.
But you primarily work for someplace in Boulder?
Yes, from my house in Wheaton.
Mm-hmm.
I have a 30-second commute to the other side of my house.
Yeah.
Commute to that.
Bye, everyone.
Take care.
Nice seeing you, Sam.
What's your current directory? That might be the problem.
Oh, okay. Let's see. So, I should be in my run directory. Is that the test case? Should I?
Yeah, that UFS form start.
Okay. Let me try that. Oh, perfect.
There we go.
Thank
Good.
you.
All right, sure.
Thank you. Really appreciate it. I think this is really nice ideas and to have this.
All right. Well, thanks for joining the workshop. Appreciate it.
Thank you. Bye.